Hello everyone. Good evening. Is anyone there or are you able to hear me? Please let me know. If you can hear me, we can start. And today is soil fertility. As we all know, it is probably the most important aspect of soil science from the question answer point of view. Yes, because when we were analyzing the last previous year papers, we saw at least 25, 27, 30 questions like that. Yes, sir, we can hear you loud and alive. Yes, that should be the Josh, right? We should be very loud and alive. And today's fertility is easy, as you all know. It is definitely easy, but it carries lots of questions. Too many questions come from fertility. At least while we were analyzing, if you consider the whole fertility, at least 25 is the minimum. And the questions can go as high as 28 also. All right. So without wasting more time, let us start. All right. So today is soil fertility part 1. We will be covering until the micronutrients. Like I plan to cover that much. Let's see if it can happen. And after this, one day after, we will be having the part 2. All right. So shall we start? Please write start in the comment or something so that I can start. Shall we start the session? Are you ready? Chaliye, let's go. Let's go. Yes, sir. Let's go. Okay. So I think you all know me by now. There is no point in telling who I am. So moving on. All right. So we will be starting today's class with a doubt from the last session, right? I specifically remember Vipin. Vipin was telling me, yes, good evening, very good evening. I specifically remember Vipin Yadav was telling me कि sir, temperature के साथ तो inverse relation है, right? Do you remember? This is the thickness of the double layer, right? Diffuse double layer का thickness का ये equation है, correct? Do you guys remember? We were having a discussion on this, and उसमें I have taken this equation. This equation is from old ISSS only, and here you can see, as per the equation, thickness is directly proportional to root over temperature. All right, but we all know actually it is inverse. Like temperature बढ़ने से we know that the thickness decreases. Do you guys remember? We had a doubt on this, Vipin. Yes, Vipin. So I have taken the, like last class, I was also a bit confused. So sorry about that. This class, I have taken the specific explanation for you. All right. So not ISSS was wrong. I was also not wrong, but we were not entirely correct also, right? So here the problem is the two opposing temperature vectors are taking place. This is the direct kinetic effect and this is the indirect dielectric effect. Here you can see both this epsilon, that is the static permittivity of the medium, and this temperature, both are in the numerator, right? Both of them are in the numerator and both are related directly proportional, right? Now there comes the problem. So the direct kinetic effect, this effect is this T that we are seeing here, this is this T. So it is telling that absolute temperature is in the numerator of the equation. Therefore, an increase in temperature directly increases the kinetic energy of the counter ions in the soil solution. This results in a expanded diffuse double layer proportional to root over T. All right. This is very common sense only, because since T is above, and also we know by common sense, if you are increasing the temperature, the kinetic energy will increase and the thickness of the double layer will increase, right? But the problem arises with this indirect dielectric effect. The problem lies in the relative permittivity, that is the epsilon, which is also in the numerator. The dielectric constant of water is highly temperature dependent. dielectric constant is highly temperature dependent. This is very important, and it is inversely proportional to temperature. As the soil pore water heats up, increased thermal energy disrupts the hydrogen bond network and the alignment of water dipoles, significantly suppressing the solvent's ability to screen electric charges. So this direct effect results in increase in thickness, but this indirect effect results in decrease in thickness. That is why Vipin was telling it was inversely proportional, but if we can see in the equation, it is directly proportional. So the question comes, these are the two factors. Who will be the controlling factor then? So here you can see I have written for you the net macroscopic effect. What happens is the net change in the diffuse double layer thickness depends entirely on the product of these two variables. However, in aqueous clay electrolyte systems, the decline in the dielectric constant outpaces. That is, this becomes a major process than the increase in absolute temperature. So is it clear? Is it clear, Vipin? Or anyone who else is watching? Is it clear now? The problem is with these two variables. This static permittivity, that is the dielectric constant, and also this temperature, both are directly proportional. So this variable is increasing the thickness, but this variable is decreasing the thickness. So the net effect is the decrease. All right. So we started with a bit of chemistry, and now we are entering the domain of soil fertility. So soil fertility, see, you all know, majorly it is you have to just read and you just have to remember. There is not much concept, but wherever there is concept, I will try to make it very simple and very easy for you. All right, so let's start with soil fertility. We all know the definition of soil fertility. These are the keywords. You should remember the keywords. Wherever in question, if you see inherent capacity of soil, go for soil fertility. So it is the inherent capacity of soil to supply plant nutrients and water in adequate amounts and in suitable proportion. Bas, this is much. Then soil productivity. The difference between fertility and productivity, it's a very known question. You can get it. So soil productivity is the soil's capacity to produce certain yield of crops with optimum management, and this is very important. It is generally measured in yield units. All right, generally measured in yield units. So it is dependent on lots of factors, as you can see: planting date, fertilization, irrigation schedule, tillage, cropping sequence, pest control, and there might be n number of other factors. So soil productivity is a function of soil fertility plus management plus climate. We all know that. So this statement is the final statement that you should remember. All fertile soils are not productive, but all productive soils are certainly fertile. Productive का मतलब है कितना production वो कर रहा है. So if it is productive, naturally it is fertile, because without fertility it cannot produce. But a soil might be fertile but not productive because of other constraints. यहाँ पे जो इतना सारा factors है, it can be due to some environment constraint, it can be due to the problem in planting date, it can be due to problem in irrigation. All right. So this is very easy concept. We will not waste much time here. So coming to the criteria of essentiality. This PPT we have made for you so that you can get a quick revision. Everything is given here. Criteria of essentiality. It is considered essential only when, I have underlined the keywords for you also, cannot complete its vegetative or reproductive stage of life cycle without that element. The element is directly involved in plant metabolic function, and it should not be used just for mere correction of the medium. And finally, it is specific, that is, no substitution is allowed. Like there is a deficiency of molybdenum, you have to supply molybdenum to correct it. Otherwise, with the supply of boron, it cannot. Yes, Vipin, we will come. Everything is there, don't worry. So this is very important. These things you all know, I know. Exam is in 1 month, so telling these things is a waste of time. You all know, but what you should remember, that I will tell you, so that you remember the keywords and question galat na ho, right? In this, you have to remember these underlined parts, and here you definitely have to remember the name of the scientist as well as the year, both. 1939 भी याद होना चाहिए, नाम भी याद होना चाहिए. Then essential plant nutrients, we all know the number is 17. Then it is divided into major or macro and micro. Out of macro, we all know it is 9, micro is 8. So out of the 9, these are the framework elements, or these elements make the structural framework. These are taken from air and water. Since it is ये free में मिलता है, that's why we are not concerned about its deficiency. We are not concerned about its chemistry, because air or water से plant इसको free में ले लेता है. So this is not much of our concern. Then these are called the primary nutrients, that is NPK. Secondary nutrients, calcium, magnesium, sulfur, and micronutrients are these 8. So which will qualify as a macronutrient? Which will qualify as a macronutrient? Yes, these are structural elements. Which will qualify as a macronutrient if the plant requires it more than iron or chlorine. All right, we all know this. These are known facts. So why these primary nutrients are called primary nutrients? Because these are needed by the plants in relatively larger quantities, and also these have universal widespread deficiency. Please remember the 3 points. These are required in large quantity, these are having widespread deficiency, and finally we have to supply fertilizers, straight fertilizers, in which one of these 3 elements should definitely be present. That is why these are called primary elements, primary nutrients. And secondary are because these are required in less quantity. These are required in less quantity than that of primary, and also these have, please remember this term, these nutrients have localized deficiencies and not widespread. These are having localized deficiencies, and these deficiencies are generally alleviated by the apply of primary nutrient fertilizer only. Yani ki we are supplying SSP, we are supplying the single superphosphate, that is also supplying gypsum, which is supplying calcium and sulfur, which is making the deficiency of secondary nutrients also corrected with that. All right, ultra micronutrients, yes. No, cobalt कहाँ से आया? Cobalt is not essential. Cobalt is still not essential. According to ICCS, we cannot consider. Ultra micronutrient is molybdenum. उसके साथ we can take nickel also. Cobalt, though still now it is not considered. Like we cannot. However, it is under consideration. Yes. Very good. So secondary nutrients समझ में आया? These are having localized deficiencies, और इसका deficiency, just to correct their deficiencies, we do not have any specific particular fertilizer. We can supply any primary nutrient fertilizer, and with that the carrier material and all other things, this will be alleviated. Very nice. Okay, now coming to the ICCS definitions. We all know these definitions. I don't think we have to waste much time here. So what is available nutrient? You have to read this. Only read the keywords. No need to memorize everything. Just read the keywords. Available nutrients, readily absorbed and assimilated by the plants. Readily absorbed and assimilated by the plants. It is only a small portion of the total nutrient in the soil. Its variation in amount is responsible for significant changes in yield and response. This last line was told by Bray in 1948, right? So this is available nutrient, very important. Then beneficial element, I think you all know, exam is just less than 1 month away. So beneficial elements are the mineral elements which stimulate plant growth but are not essential, or which are essential only for certain plant species, which are essential only for certain plant species. These are called beneficial, or these are essential only under specific conditions, right? You have to remember all these names. Iska, you can make some mnemonics, otherwise it is very easy to remember. Si, na, ko, se, val. All right. Silicon, sodium, cobalt, selenium, vanadium, aluminium. Here you can see all those are written. So you have to remember the example. And iska sabse bada example hai like silicon. Silicon is a beneficial element, but it is a essential for rice. So for specific crop, for particular crop, it is essential. So that is a beneficial element. Then coming to functional nutrient, someone was commenting, Vipin, I think. Yes, functional nutrient, the term was given by D.J. Nicholas in 1961. You have to remember the year and also the name. What is a functional nutrient? It is an element that plays a role in the plant metabolism, whether or not that role is specific or indispensable. So even if the role is not indispensable, even if the role is not specific, it plays a role in plant metabolism. That is called a functional nutrient. All right. Trace element, we all know. Trace का मतलब है बहुत कम trace amount. So an element found in very low concentrations. perhaps less than 1 ppm or still less in soil, plant and water, that is called a trace element. Sir, how are you? I am very fine, Shomik. Thank you for asking. Tracer element, trace element or tracer element may you might get confused, so be very aware. Trace and tracer are very confusing. You might feel sometimes it is very confusing, but it is not confusing at all. Trace का मतलब है trace amount of पढ़ाई करने से JRF crack नहीं होगा. You have to read more, right? So trace मतलब small. So an element found in low concentration, that is trace. But tracer का मतलब है, tracer you all know, right? We use tracing. We used tracing papers in our school days and all. So trace matlab that traces the pathway of something. That is called a tracer. So tracer is nothing but these are the radioisotopes or a stable isotope of an element that is used for tracing its path in a system to study the mechanism of its interaction with the system, right? Isotope technique for studying nitrogen cycle, Burris and Wilson, very nice. So इसका मतलब क्या है? Tracer मतलब it is tracing the pathway of something, that is why it is called tracer, and trace का मतलब है कम. So how this tracer technique is used, I think all of you know. This tracer technique is having isotope. Isotope का मतलब है same proton number, but it is different in mass number. So it will have almost similar chemical activities and chemical properties, but you can detect it using some detectors. So when you are applying that isotopic tracer in the soil plant system, the way it will go, you can trace the whole pathway, and with that you can make an idea that how the actual pathway of the nitrogen or the whatever it works. All right. So it is like normal nitrogen moving through a pathway. You are supplying the tracer from outside, that is also moving in the same pathway, and just by detecting that tracer, you can detect okay, the pathway or the metabolic pathway works like this. All right. This table I cannot emphasize enough. This is very, very, very important. I know all of you have read this very nicely, and this is extremely important, especially the first, this column, and this column, so you all know. So these three columns are extremely important. This column also might come, this column also might come, but those three are extremely important, right? So इसमें तो explanation का कुछ नहीं है. You have to read this. This table you have to read. It is in old ISSS, it is in new ISSS, it is in treatise. जहाँ सा भी मन है पढ़ लो. I specifically remember this question. This question came during 2022 JRF, which I gave as a mock JRF. In that, this question came. So this is also very important, this column. What is the plant usable form? The plant uptakes the nutrient in which form? That you have to remember. For nitrogen, you have to remember nitrogen and all, ये तो याद रहता है. The problem is with the micronutrients, so you have to remember these all right? Especially this boric acid, you know. Then iron, chlorine, sulfate and everything. और ये सारे names तो याद होना ही चाहिए. Specifically in this, you should remember the year of nickel, because we all know nickel is the most recently introduced micronutrient. So you have to remember the year of nickel, and also who were the inventors. Who were the inventors? You have to remember all. Everything is important. You cannot just skip this. All right. यहाँ पे जब हम we were discussing this in the micronutrients, I think you all know that there is again two division, micronutrient cation and micronutrient anions, right? Can you please write which are the micronutrient cations and which are the micronutrient anions? Until the time I drink some water, can you please write that? Which are the micronutrient cations and which are the anions? यहीं पे सारे लिखा हुआ है. You can just see and you can write. सिर्फ Cl- लिखने से कैसे होगा भाई? Non-ionic micronutrient is boron. You are correct. Like it is, we all know it is uptaken in the form of boric acid, but still you have to consider it in micronutrient anions only. You have to consider it in micronutrient anions, because if you closely see the table, boron can be taken in this form as well. H2BO3 minus or These two forms can also be taken, although it is negligible, but again it can be taken in this form. So you cannot say it is non-ionic. It will also come in anion only. All right. So moving on, these are again the definitions that are very important. Deficient. What is a deficient? When the concentration is low enough to severely limit the yield. These are the keywords. I have highlighted the keywords for you. ये PPT एक बार, ये PDF एक बार पढ़ लेना. That would be brilliant. Deficient, low enough to severely limit yield. Critical range is below which a yield response to added nutrient occurs. Then sufficient is added nutrient will not increase yield but can increase the nutrient concentration. The term luxury consumption, this is very important. It is often used to describe nutrient absorption by the plant that does not influence yield, right? Which nutrient element shows this? Please write it in the comments. And what is excessive or toxic? When the concentration is high enough to reduce plant growth and yield, right? There is some yield penalty. If there is some yield penalty, that is toxic. इतना ज़्यादा प्यार और नहीं हो रहा. Yes, it is K. Of course, all of you know. So toxic is you are giving so much of love, that is toxic. The plant is not able to take it. That is a toxic. All right. So after these definitions, I will draw a graph for you before the Liebig's concept. So here, you know heavy metal. Heavy metal, I don't think heavy metal is having specific gravity of more than 5 or having atomic number higher than 20. That is, anything heavier than calcium is termed as a heavy metal. This is straight taken from old ISSS. All of you have read by now many times. So what is nutrient content? Nutrient content का I don't think definition पढ़ने का कोई ज़रूरत है, but you have to remember this unit. How you can express the nutrient content, right? Nutrient content is actually a ratio if you see. ppm is nothing but it is a ratio 1 by 10 to the power 6, है ना? Then nutrient accumulation. What is nutrient accumulation? It is storage of nutrient in a particular part or portion of the plant. It is called nutrient accumulation. Different plant parts store nutrients differentially. We all know this. For potato, it is stem. For sweet potato, it is root. For onion, it is leaf. For mango, it is fruit. So जहाँ पे plant store करता है, हम जाके उसको खा लेते हैं. That is nutrient accumulation. Then nutrient uptake. Uptake is very important. Uptake is very important. So it is the amount of nutrient taken up by the growing crop from either the soil or other sources is called nutrient uptake. It is a product of plant matter produced and nutrient concentration in plant. So this formula is also important. What is nutrient uptake? Nutrient uptake is the plant matter produced, remember the unit, into nutrient concentration. Please remember the unit. So multiplication of this is this. So before coming to Liebig's law of minimum, I would like to draw a graph for you. If you have pen and paper with you, please draw the graph with me. This will be very important. And I will ask you questions also. Please answer the questions. Huh? This graph is very, very important. Any day you can get questions from this. All right. Both in your objective and in your subjective. So this is the growth curve. All of you can see. Now I will delineate some zones. You have to tell me which zone is what. All right. Now, can you tell me which is the name of this zone? Last zone is toxic. Yes, you are very correct. Last zone is toxic. Definitely it is toxic, but not the extreme last zone. This part, like this part where the yield is further decreasing with increase, this part is called lethal. This is called lethal. Okay. First one is deficiency. Very good. Who is writing? Pawan. Yes, very good. First one is deficiency. Then can you tell me the second one? Second one is hidden hunger. Perfect. This is the hidden hunger. All right, this zone. Here you can see, like with increase in concentration of the nutrient, the plant growth is increasing, but it will not show any deficiency symptoms. So it is very difficult to understand whether the plant needs this nutrient or not. That is why it is called hidden hunger, right? मतलब उसको भूख है, but he is very shy. He is not showing it in front of the world. Okay. Third is luxury consumption. No. Third is wrong. Pawan, third is wrong. This one is the third zone. What is this? This is the most important zone, right? Kate and Nelson ने दिया था. This zone is the most important zone. Not sufficiency. Sufficiency is के बाद. This zone is sufficiency. This zone is sufficiency, and it also consists of luxury consumption as well. Because even if you increase the nutrient concentration, there is no increase in yield, and the plant can just take the nutrient, right? Bioavailable nutrient. No. There is a term, specific term. C से शुरू होता है. C. इतना कुछ बोल दिया. Now I think it should be very easy. This is the which limit? Yes, that is the critical range. Yes. This range is the critical limit or the critical range. This third part is the critical range. Critical range क्यों है? Because this is the range only in which we have to calculate our fertilizer calculation and we have to supply fertilizer, right? This is the critical range. This range only will decide, because you see, इसके बाद if you continue applying fertilizer, there is no material gain, so you will have loss. You will just have to pay for the fertilizer, but you are not getting any yield gain. So this range is the critical range, which is critical for all fertilizer calculations, all fertilizer recommendation. Kate and Nelson's critical limit, then targeted yield concept, everything is based on this range. All right. Now, here I have given one arrow. Can anyone tell me what is this? This portion is what? Can you guess what is this portion? Anyone? Any guesses would do. Which is this portion, this arrow portion? Acute deficiency. Okay, you are kind of on the right track, but it is one effect. It is called one effect. Deficiency visual symptom तो ये है. In this only you will have deficiency visual symptom, this part. After this, the hidden hunger is there. Here you will not have symptom, but it is deficient. This part is the deficiency symptom. But uske bhi niche, this part. This part is Steinberg. Yes. Perfect. I'm very happy. Dilution and Steinberg effect. Yes, that is very nice. You guys are definitely on the right track. This is the Steinberg effect or the dilution effect. All right. So I hope you enjoyed this graph. This graph has been taken from Brady and Weil, जिनका book का नाम है Nature and Properties of Soil. I think you all know. You should remember also the name of the book. So this is a very interesting and good graph, and this will come in handy for you. Also known as Steinberg-Piper effect. Yes. So what is Steinberg effect? I think all of you know. It is the dilution of some specific nutrients due to the overabundance of other nutrients, which is happening in our Indian soil a lot, right? We are supplying so much of N, P and K. The plant yield is increasing, but the nutritional quality of the plant is decreasing because since there is so much of nitrogen, there is so much of phosphorus, there is so much of potassium, the plant biomass is increasing, but the nutritional quality of the plant is decreasing because it is getting diluted. है ना? The biomass is increasing so high, but the nutritional quality is not that much. This is the problem with the Indian population nowadays also. We are not having nutritious food, because after Green Revolution, we got immense increase in yield, but nutritional quality could not be increased. All right. So coming to the law of minimum, these are again, we are coming in our similar domains, nothing to read here. So Liebig's law of minimum, I think you all know, this is called the barrel concept. In this, the step of the barrel, which is the least, which is the sabse chota, that will decide the amount of water in the barrel. So once this, after this, if this is the second most least, then this will decide. Then once the water empties, then this will decide. Like that, you all know this barrel concept. Tandon and Chemo 1993 pictorial depiction. Okay, very nice. So the barrel concept states that if one essential plant nutrient is deficient, plant growth will be poor even when all the other essential nutrients are abundant. This is very easy. इसमें कुछ बोलने का नहीं है. Now, Mr. law. Mr. law is important. Steinberg effect in additional but severely decrease in nutrient. Yes, very good. This I think you all know. This is Mr. law. Mr. gave two laws. I have forgotten to write the years here. Please remember the years as well, because that also might come, right? So Mr. law of physiological relationship. This is also very important. Mr. law of physiological relationship, very important. It states that yield can be increased by each single growth factor even when it is not present in the minimum, as long as it is not present in the optimum. This is very easy to understand. There is nothing hard. Now, Mr. growth law is a bit tricky, but I don't think it is tricky enough. So, Mr. growth law is increase in yield of crop as a result of increasing a single growth factor is proportional to the decrement from the maximum yield obtainable by increasing that particular growth factor, right? If you want explanation of this law, I will explain, or we will move ahead, because these are very easy things you have read for so long from third year, fourth year maybe. So this is the equation: log of a minus y is equal to log a minus cx, or dy dx equal to a minus y into c, where these are the, this c is also called efficiency factor or the proportionality factor. If you want explanation of Mr. law, I will explain, otherwise we will go ahead. Please let me know. It is clear, right? What is it telling? The maximum yield is a, the maximum yield is a. Go ahead, sir. Yes. So this, it is telling the increasing in yield is proportional to the decrement from the maximum yield obtainable. So that is very easy. This is the maximum yield, and say at a particular point the yield is this. So the yield increase will be proportional to this. Now after some application of growth unit, the yield becomes this. Then the yield increase will be proportional to this. This is also called the law of diminishing marginal returns. I know you all have read economics. This is also called the law of life. So which is the very easy way to understand this? Suppose you are having law of max element, language remembering is hard. Yes, Shomik, because these laws were not all written in English, you know. These scientists were German. Mr. law was actually written in German. German se translate kiya gaya hai English mein, that's why this comes. So it is also called the law of diminishing marginal returns. What it says, say you are having some sweet, you are having peda, all right? You are eating peda in your house, you start eating, you eat one, you feel very good, you eat two, you feel very good. Like that you continue eating until 4 or 5 you will feel very good. Then after that, when you start eating more, you are eating 6, 7, 8, then the satisfaction level per peda, that will start going down, because you will feel very sweet and you will not feel that much satisfaction which you were getting when you first ate that, right? So the same with the plants. When you are applying, yes, it was in economics course, exactly. So when you are applying fertilizer in the plant, first the plant will go on giving the yield very nicely, but if you keep on increasing giving the fertilizer, the plant will also show a decrease, a marginal decrease, because with every increase in input use, the marginal utility of that decreases. All right. Rashogolla, Rashogolla bhi kha sakte ho bhai. So percentage yield concept, it was given by Ball, we all know, 1918. When more than one nutrient is deficient, the final percentage sufficiency is the product of individual sufficiency. This is also from old ISSS, very nice. So example, if phosphorus is adequate for 80% yield, potassium is adequate for 70% yield, then final yield is 70% of 80%. That means 70 by 100 into 80, and that will be 56%. So this 56% will be the final yield obtainable. This is Bowley's percentage yield concept, and you have to remember Bowley unit 223 pound. Please remember the unit. I tell it again and again. kg per hectare में लिख के मत चले आना. This is not in kg per hectare. This is in pounds per acre, right? So it is 223, 45, then 76. All right, and also remember this. Yes, it is not only P or K. It is P2O5 and K2O. All right. Bowley unit. Can anyone tell me what is a Bowley unit? This is the percentage yield concept of Bowl. That is okay. What is Bowley unit? Can you define Bowley unit? What is one Bowley unit? Like 223 pound per acre nitrogen देने से क्या होगा? What will happen? It is the unit of input required for, yes, achieve 50% yield. Perfect. You guys are right on track in your preparation. It's very good to see. Unit of growth factor required for 50% yield. So first Bowley unit will give 50% yield. Then the second Bowley unit will give 50% of 50%. That is 25% yield. Then the third will give even. Are Supriyo Mondol sir, welcome. So this is the coming to the law of maximum. This was given by Wallace and Wallace in 1993. You should remember the year also, and you should remember the name of the scientist as well. So what it says, when the need is fully satisfied for every factor required in the process, the rate of process can be at its maximum, which is greater than the sum of individual parts because of the sequentially additive interaction. तो इसका statement तो याद रखना ही है, but normally what we can say, if we are supplying factor A individually, if we are supplying factor B individually, तो इन दोनों का जो growth होगा, that is A plus B, it will not be equal to when we will supply A, B together because of positive interaction effect, because of this sequentially additive interaction. When we are applying unit A, pura, it is based on synergistic approach, yes. When we are applying unit B individually, that will also give some yield. But if we add them individually, then that will be less than, not equal, and it will be less than जब हम A और B एक साथ देंगे because of sequentially additive interaction. All right, these are very easy. Now we have come to Bray. Finally, we have come to Bray. Bray concepts of nutrient availability. According to Bray, 1938, available form of nutrient are those forms whose variation in amount in soil are responsible for significant variation in yield and yield response. Right? This is the definition you have to remember. There is nothing. Bray postulated that availability of these forms involves not only chemical and physical nature, but also the ability of a plant to forage them with its root system. Right? Nothing to read here. Then, after 1938 came 1954, Bray's concept of nutrient mobility. Bray defined mobility as this one is important. This one comes in exam. I myself have seen this statement, especially this statement. This statement comes in exam where they will ask you true or false or assertion reason, you know. So please be very thorough. So Bray defined mobility as it is the overall process whereby nutrients reach the sorbing root surfaces, thereby making possible their sorption into the plant. So it is all process, every process that is involved in this movement of the nutrients to reach the sorbing root surfaces. All right, this is one. Then mobility involves the solution or exchange of the nutrient as well as the movement to the root surface. So it is the overall process, every process that makes the absorption happen. Everything comes under mobility. So you remember, please remember this definition. This comes in exam. So we all know Bray then classified the nutrients into two categories. One are the anions, nitrate, chloride or bicarbonate. which are not adsorbed by the solid phase, we all know because we had extensive discussion in the last class. Solid phase has negative charge, these are also having negative charge, so repulsion hone ki wajah se there will be no adsorption. So it remain in solution and are carried away to longer distances in response to their adsorption by plant roots. Such nutrients are mobile, whereas cations like A, Mg, Ca are held on the negatively charged surface of the colloidal clays and organic matter. This can be replaced by and are in equilibrium with the cations in soil solution. These are immobile nutrients, right? So concentration controlled by all this is not that important. Then there are the concepts of root system sorption zone and root surface sorption zone. This photo is again from our beloved ISSS. So here you can see this is the root system sorption zone. So if a nutrient is mobile matlab it can move around. If a nutrient can move around, then it can be present in any part of this root system sorption zone and it will be absorbed by the root, right? But in case of immobile nutrients, when the nutrient is immobile, that is it is fixed to the soil colloid, it does not move, in that case it has to be present in the root surface sorption zone, otherwise it will not be absorbed by the plant. So in case of immobile nutrients, if it is present in the root system sorption zone, it cannot travel and get absorbed, right? It is that easy. Here you can see the root system mobile nutrients and root surface sorption zone immobile nutrients as proposed by Bray 1954 for nutrient management depending on mobility. This table is again very important, perhaps the most important of ISSS. You have to remember this all and you have to remember these exact forms also. All right, you have to remember. So which is in plant, which is mobile, which is immobile, in soil, which is mobile, which is immobile. Remembering in soil is very easy, we all know, because all the mobile ones are the anions with the exception of molybdenum and phosphorus. Molybdenum and phosphorus anion hone ke baad bhi they are immobile in soil. Why? Because of ligand exchange and specific adsorption that we will see later in phosphorus and we'll explain also. So all the anions in soil are mobile, all the cations in soil are immobile with the exception of these three. But in plants, you have to remember which is mobile and which is immobile, all right? Now we are coming to nutrient movement, right? Movement of ions, nutrient movement we have come. Movement of ions from soil to root, it is the mechanism of nutrient transport. Nutrient transport, ion absorption, we know it requires contact between the ion and the root surface. There are three ways, exactly three ways: root interception, mass flow and diffusion. You all know this. There is nothing new, right? So first we will see root interception. So इसमें क्या क्या पढ़ना है, the keywords that I have specifically taken for you, and these are very important, you have to remember. First you have to remember the name of the scientist who gave the concept and also the year 1939. So Jenny and Overstreet propounded the theory of contact exchange or the theory of cation exchange. This is taken from old ISSS. Then exchange of ions through physical contact between the root and the mineral surface. Ion absorption by root interception is enhanced by increasing the quantity of absorbing roots in given volume of soil. That is normal common sense. Then you can read all this. This part is also important. Oscillate within certain volume. The ions held by electrostatic forces at these sites oscillate within certain volume. When these oscillation volume of two ions overlap, ion exchange occurs. So root interception was given by Stanley A. Barber. Yes, the term was given, but this theory of cation exchange was given by Jenny and Overstreet. But the term root interception was given by Stanley A. Barber. Perfect. Mass flow given by Munch. Diffusion given by Mulder. This theory of contact exchange is in root interception only, right? It is only the theory of contact exchange. What's the problem? The term root interception was given by Stanley and Barber. Diffusion is governed by Fick's law, right? Anyhow, you open the old ISSS and you start reading from the first line. This is in the first line only. Jenny and Overstreet gave the theory of contact exchange. The term root interception, it is written in the second paragraph. In the next part of the page, it is written Stanley A. Barber, right? Anyhow, so oscillation volume, you should remember the keyword oscillation volume. And then when the oscillation volume of two ions overlap, ion exchange occurs. This is also very important. Then these two are just for your information. You can remember the values. And root interception of nutrients can be enhanced by mycorrhiza. This is also common sense. These two are the pictorial description. This is also from old ISSS. If you remember, clay plus metal, H root, it exchanges, and this is the oscillation volume where the exchange is happening with physical contact of the two ions, right? Then coming to mass flow was given by Munch. Yes, Vipin Yadav has written, very good. So it is the movement of nutrients through the soil to root in the convective flow of water. All these are keywords which are in bold. Through the soil to the root in the convective flow of water caused by the plant water absorption, right? Amount of nutrient moving through mass flow, J, is determined by rate of water flux into roots, that is V, nutrient concentration in soil solution, that is C. So J equal to V into C. Mass flow can supply an excess of Ca and Mg. I think we have had extensive discussion about this part. Please remember, Ca and Mg is supplied by mass flow. Several micronutrients and soluble mobile nutrients such as NO3, Cl and SO4, we know that. Mass flow is reduced due to reduced soil moisture and low temperature. This is also very common sense only. If soil moisture is reduced, then definitely mass flow will reduce, because mass flow is through the soil in the convective flow of water, and low temperature means low kinetic energy and low evapotranspiration, so the water movement will again be slow. Here you can see this is the mass flow. These are very easy things. Diffusion occurs when an ion moves from an area of high concentration to one of low concentration due to, this is important, due to thermal motion or Brownian motion. This is the reason. As roots absorb nutrients from the surrounding soil solution, the nutrient concentration at the root surface decreases compared with the bulk soil solution, creating a concentration gradient that causes ions to diffuse towards the root, right? Very important. Fick's law. Fick's law is the law that is governing the diffusion. We all know that. Fick's law, the amount of nutrient ion diffusing across a unit area in unit time is directly proportional to the concentration gradient. This is also called the flux. So this flux is directly proportional to the concentration gradient. Flux of diffusing ion, dc dx is concentration gradient, change in concentration with distance. D is the diffusion coefficient. Please remember the unit. This is very, very, very important. VVI. You can get it in match the following. You can get it in direct question. You can get it anywhere. This unit of diffusion coefficient. And finally, this negative indicates movement from higher to lower concentration, that is opposite to the direction of concentration gradient. So always remember, a gradient happens from lower to higher. This is called a gradient, but the movement happens opposite from higher to lower. So it is opposite to the concentration gradient. That is why there is a negative sign. This negative sign indicates the minus, right? Now the nutrient flux that I was telling, I think I have discussed this before also in the question answer sessions. Yes, so here I will tell it for you again. Amount of anything, right? Amount of anything, be it mass or volume, does not matter, mass or volume, per unit area per unit time, that is called flux, right? So nutrient is mainly transformed from soil to maximum percentage of nutrient is, maximum percentage happens through diffusion only, right? In case of gas also, in case of movement of nutrients also. Anyhow, so this is called flux. So amount of anything flowing per unit area per unit time, that is called a flux. So you take this flux और इसको proportional कर दो hydraulic gradient के साथ. Flux of water proportional to hydraulic gradient, that is Darcy's law. Flux of gas proportional to partial pressure, that is Fick's law for diffusion of gases. Then flux of nutrient ions proportional to concentration gradient, that is Fick's law for diffusion of nutrient ions. Then this flux of heat is proportional to thermal gradient, that is Fourier's law. All the law are analogous, everything is same. Ohm's law will also come here. It is proportional to electrical conductivity. All the laws, the basic structure is same, you just have to remember. And Pawan here has written the unit of flux, that is very good. With the unit only you can see gram per centimeter square per second. This is the unit of ODR, right? That is also flux. Yes, you are asking mass flow or diffusion. This is also a confusion. But as far as I know, I think it is diffusion only. But if you can get it directly somewhere, I would suggest please consult that. So this is the unit. With this, you can specifically see this G is the unit of this numerator. This centimeter square is this unit area. This second is this unit time. So any type of flux you will see, it will have this unit, right? So we are done with the laws and everything. Now we are coming to specific nutrients. So इसमें तो I am not going to read everything because this you have to remember. यहाँ पे कुछ नहीं है. I will just tell you the key points, the key words which you need to remember for exam. So nitrogen we all know. Remember the group and remember what they are called. Nicogens. Nicogens comes from what? Can anyone tell me what is the meaning? Why they are called nicogens? Yes, the Greek words mean suffocation. Very good, very good. Pawan, you are giving JRF physical science or what? You are JRF aspirant. Nicogen Greek word means suffocation. Yes, Shomik, you are also absolutely correct. It is called suffocation. You have asked something. Sir, it is true that Vipin told. What has Vipin told? Going to meet you in IRI, sir. Very good. I would be so happy if all of you come to IRI. We can have a meet, definitely. So yes, moving on to nitrogen. It is called nicogen or it is group 5 elements, combines with CHO and sometimes S to form amino acid. This you all know. Definition, in deficiency, remember stunted, remember light green, remember yellow, and also this. This has been specifically taken from new ISSS. It is not, this term is not there in the old ISSS. Paling and pigmentation when severe, dry and necrotic botches of tissues appear, that is also called firing. So, as a specific term jahan pe hota hai, they might ask from that, what is firing, like which deficiency causes firing, you have to write nitrogen. For this, I will suggest all of you to read treatise. Treatise is very, very, very good for this portion, where they have listed all the deficiency symptoms and they have given only the important deficiency symptoms and the important functions. That is perfect. I don't think there is any need to read anything more than that. Treatise will be very good for this. And excess symptoms you also know, dark green, lodging, pest and disease attack, so on and so on. Yes. Role of nitrogen as a plant nutrient, we all know essential constituent protein, amino acid, this and this. As a pollutant, the role is N2O emission. N2O emission leads to imbalance of nitrogen cycle, global warming, because N2O has a global warming potential of 273 in a 100-year time scale, right? We all know N2O is 273 times more harmful than CO2 in case of global warming. It also aids in ozone depletion. Nitrogen is often referred as universally deficient nutrient. This is also a keyword जहाँ से question आना बहुत ज़्यादा possible है. Nitrogen is also called universally deficient nutrient, right? N2 emission के साथ साथ pollutant के हिसाब से ammonia volatilization भी होता है. This ammonia volatilization also leads to lot of pollution, because this ammonia volatilization leads to formation of PM 2.5 and PM 10 particulate matter, and it will be fatal when you respire that. All right. Forms of soil nitrogen. यहाँ पे याद रखने का चीज is this. How much is organic nitrogen? How much is inorganic nitrogen? Inorganic ka forms, I think all of you knows. Out of this is very very transition form. This is not much. Yes, NPSZN, order of deficiency, perfect. हाँ, universally deficient से याद आया, if they ask which is the deficient nutrient in Indian soil, the answer will be nitrogen. If they ask which is the deficient micronutrient in Indian soil, then the answer will be zinc. So it seems very easy कि सर zinc तो micronutrient है तो zinc ही आएगा ना उसमें तो nitrogen नहीं आएगा. But trust me, in exam you will make this only wrong when they will ask which is the most deficient micronutrient or option 1 में nitrogen रहेगा. Trust me, at least 50% of you will mark nitrogen and come. I am also from the same category. I have also endured all this, So it's nothing wrong. That's why I always tell you, please read the question at least twice and read all the options, all the 4 options. Even if you are definitely damn sure that option 1 is the correct answer, please read the option, all the 4 options. All right. Most plants take nitrogen in the nitrate form. This is also very easy, right? Then few plants take nitrogen in ammonium nitrogen form. Example is rice, cotton and sugarcane. This is also very easy. Fate of nitrogen in soil. This is also a very nice table. This has been compiled by Rohit. I must give him the credit. He is also a mentor in our AgriAddict only. You can see his revision on the upcoming topics. So fate of nitrogen in soil. Ammonium will lead to nitrification. Just by reading this table, you will remember which processes are there. Nitrification is what? Nitrification is ammonium to nitrite to nitrate. All right. Please do not forget this. And also do not get confused with nitrification and nitrogen fixation. Please never get confused with that. Then ammonium will lead to the formation of ammonia. Ammonia with the release of 1H plus, and this ammonia will volatilize. Then fixation by clay minerals, we all know that is a positively charged ion. Then plant uptake like rice. Then it remain in soil solution as NH4 plus, definitely. Immobilization by soil microbes. Soil microbes can also take ammonium and assimilate it, right? Nitrosomonas and nitrobacter responsible, or भी microbes hai, but these two are the most common. Yes, you are correct, Pawan. Then what is the fate of nitrate in the soil? Nitrate, plant uptake is the major fate. Then denitrification. Denitrification, I think you all know. Sequential reduction of nitrate into other things. I might have made any mistake here. We will go see it in detail. No, don't worry. Leaching is nitrate. Since nitrate is not absorbed by the clay colloid, it will go into the groundwater. It will go into the leaching. Then dissimilatory reduction. Dissimilatory reduction. This is a new process. This is called DNRA. Dissimilatory nitrate reduction to ammonium. This also we will see in the nitrogen cycle. This is also there. And immobilization is nitrate will be converted to organic nitrogen. That is the immobilization. All right. This is the nitrogen cycle. This is my most favorite nitrogen cycle. This is taken from Tisdale and Nelson. I don't know how many of you have read that book, but that is the best book of soil fertility. And I can say with full determination, this is the best nitrogen cycle you will ever find, because everything is incorporated here, right? All this you all know. This is the N2 fixation. N2 fixation यहाँ पे होता है when there is nitrogen coming from atmosphere to soil, and nitrification यहाँ पे होता है. It happens inside the soil. Please never get confused between nitrification and nitrogen fixation. All right. Nitrate reduction occurs in cytoplasm and nitrate reduction occurs in chloroplast. Exactly. And दो enzymes का नाम भी लिख दो पवन. Nitrate reduction में कौन सा enzyme लगता है and nitrate reduction में कौन सा enzyme? That is very easy. Nothing to write there. But still you can write if you want. So please remember, ये दो completely अलग है, and all the processes here you can see. If you read this PPT, if you read this nitrogen cycle all, you will remember all the processes, and it is extremely good. Here you can see aminization. Aminization is from organic matter, formation of amino acid. Aminization, formation of amino acid. Then aminization के बाद ammonification, formation of ammonia. All these are written in the words only, nothing rocket science. Then nitrification is formation of nitrate, nitrification. So here you can see this nitrate is going to leaching, this nitrate is going to denitrify, it is going for denitrification, and here this I have written as DNRA. It is called dissimilatory nitrate reduction to ammonium. So this is a short circuit pathway. This is a novel pathway where the nitrate does not enter the denitrification pathway but enters this pathway and again forms ammonium due to some microbes. All right. So some microbes will reduce the nitrate to ammonium and it is called dissimilatory nitrate reduction because it will not take. If it takes the ammonium itself, it is called assimilatory, but it is not taking and returning it to the soil pool, that is called dissimilatory. So you can see this pathway is very small and very energy saving. So this is a better pathway for nitrate and it is also not wasteful because this will again be in the soil solution pool and it can be uptaken, whereas denitrification is a wasteful pathway, right? And this CommaMox also, all these I have added. This was not in the original cycle, definitely. CommaMox is called complete ammonium oxidation. इसमें क्या होता है? Ammonium to nitrate we know is a two-step process, ammonium nitrite nitrate, but in CommaMox it happens in one single step. Directly from ammonium it will form nitrate. In a single cell, in one single step, there will be no two. Yes, perfect. Nitrate reductase and nitrate reductase. Yes, very good, Pawan. So it happens in one single step. That is called CommaMox, complete ammonium oxidation. This is also a novel pathway. You will not find it everywhere. These two are there. And finally, here you can see another red arrow. That is also called ANAMOX. ANAMOX is anaerobic ammonium oxidation. These three are the novel pathways which have chances of coming in the exam. They will not ask in this much detail, but they can ask one statement, they can ask one line, okay? So you should be thorough. ANAMOX का मतलब है anaerobic ammonium oxidation, right? It is also written in the word only. What does it mean? So ammonium यहाँ पे आ गया. Ammonium का oxidation हो रहा है. Ammonium का oxidation होके we are forming nitrogen. You can see. यहाँ से मैं arrow लेके direct nitrogen में ला दिया. But it is happening anaerobically हो रहा है. So what is the reaction? The reaction is ammonium plus nitrite, it will form nitrogen plus H2O. So anaerobic का मतलब है anaerobic, that is it will not oxygen definitely, but it will use nitrite as an electron acceptor because it is anaerobic, and using nitrite as electron acceptor it will convert this ammonium into nitrogen. This is called anaerobic ammonium oxidation and it is done by a specific group of microbes. That group is called planktomyces. All right, specific group, and in लोगों के पास there is a specialized organelle that is called anamoxazome. Anamoxazome, please remember all these words, might come. Anamoxazome organism is there which helps in nullifying the toxicity, because in this reaction in the middle there is a formation of N2H4. This N2H4 is called hydrazine, which is very toxic. That is why other microbes cannot endure it. But this specific group of microbes, they have a specialized organelle called anamoxazome that can nullify the toxicity of this hydrazine and they can form this nitrogen. All right, itna deep might not come, but there is a chance, because if you see the standard of 2025 JRF, it was quite high. So you might expect ऐसे दो चार question आ सकता है. They will just give the term and they will ask, what is the full form? What do you mean by this? They will give one statement, true or false, like that, okay? I think everything is clear. If it is clear, please write clear. I will have some water in the meantime. If you want, you can go search in Google also, in Gemini, in ChatGPT also. They will give you very nice examples to make you understand that very easily. Yes. Clear. Okay, thank you so much. So this is mineralization and immobilization. This is mineralization and immobilization. This is also nothing to say. Mineralization we all know, organic to inorganic, that is mineralization. This is plant available part, and iska ulta, opposite of that is immobilization. It becomes unavailable to plants. This table is also very, very, very important, extremely important. Please remember this also. CN ratio, when it is narrow, narrow is always good. So mineralization will happen, release of inorganic nitrogen that is available to plant. Then between 20 to 30, neither net nor net immobilization, and when it is wider than this, there will be immobilization. This will result in unavailable form. All right, ye ho gaya. And please remember one other term here. That term is also very important. That is called MIT. Can you please write the full form of MIT? अब Massachusetts Institute of Technology कोई मत लिखना यार. That is not this MIT that I am talking about. But can you write the full form of this MIT, which determines whether there will be net immobilization or net mineralization? This is the process. Everything is written in old ISSS. Old ISSS nitrogen chapter is extremely good, very good. New ISSS nitrogen chapter is also very good. Please go through both of them and you will have no problem. Please write the full form of MIT. Anyone? No one knows. What is MIT? MIT only determines whether there will be net mineralization or net immobilization. What is the full form of this MIT? I cannot see any answers. That is sad. So, are you not there, or have you not read the new, the old ISSS? I don't know. But anyhow, if you are not writing, I will write it for you. But please read the chapter thoroughly. Nitrogen is very, very important. It is called mineralization, immobilization, turnover, right? Very good, Shomik. But you become a bit late. I have written it already. Anyhow, so this is mineralization of organic nitrogen. This we have already discussed. We will not waste much time here. Aminization I already told you. Decomposition of protein and the release of amines and amino acid. Here you can see formation of RNH2. Then ammonification, formation of ammonia. So RNH2 से formation of ammonium, ammonia and ammonium are the same thing. सिर्फ एक ही H+ का फर्क है. Then nitrification, biological oxidation of ammonia to nitrate. This you all know. Factors affecting mineralization. These things are, I don't think this requires any explanation. You all know this. It will be depending on nature of organic matter, because organic material having high lignin content, very low rate. Of course, jitna resistant hoga organic matter, that will be less rate of mineralization. Then moisture is always needed because of the microbes. Microbes को अगर moisture नहीं मिलेगा, it will not work. So high rate of mineralization at field capacity, because ज़्यादा moisture भी खराब है, कम भी खराब है. So at field capacity it will be the ideal. Well drained soil enhanced nitrification. You all know that, because nitrification is a obligate aerobic process. It is a purely aerobic process, so you need air for that. Temperature, optimum temperature for nitrification is this, and for ammonification is this. Aeration, alternate wetting and drying, type of clay, pH, inhibitors, amount and source of applied nitrogen. Then we have come to denitrification. It is the microbial process of reducing nitrate and nitrite to gaseous forms of nitrogen, principally nitrous oxide and nitrogen. Influencing factors influencing are all this: pH, texture, temperature, oxygen content. It is only limited to anoxic soil. This is very, very, very important. All right. Here is a very common confusion that comes. The process is limited to anoxic soil. The process is totally anaerobic. Hear me out. The process is totally anaerobic, but the microbes that does this process, those microbes are facultative. All right, they can be both they cannot be both aerobic. They are facultative anaerobes, right? So they can survive both with oxygen or without oxygen. But the process of denitrification, that is totally anaerobic, because अगर oxygen है तो denitrification नहीं होगा, because the microbes are facultative. Facultative का मतलब क्या है? If there is oxygen, they will take oxygen. If there is not oxygen, then also they will survive. So for denitrification, you need to use nitrate as the substrate. You need to use NO3- as the substrate. So वो तभी use होगा when there is no oxygen? Bacillus? Pseudomonas कौन लिखेगा भाई? Pseudomonas लिखो. हाँ, right. So denitrification reaction sequence. So it will use nitrate. It will use. No. In nitrification, definitely there will be decrease in pH. Nitrification में decrease in pH होगा ही होगा. Of course, it will be the decrease in pH. That is why any application of nitrogenous fertilizer will result in decrease of pH in the long run, right? Because we know even with application of any urea or anything, there is concomitant rise in pH, but in long run, definitely it will be reduction in pH because of release of H+. Khair, koi baat nahi. What I was telling, denitrification, it will be the process is anoxic. It is limited only to anoxic soil. अगर submergence नहीं है, अगर pockets of anoxic area नहीं है, pockets of anaerobic area नहीं है, तो उस soil में denitrification नहीं होगा. And this has been proved experimentally also. Moisture content in the soil, that will only decide whether it is anoxic or oxic. Yes, in the long run I am telling it will decrease, definitely. Then the concentration of nitrate in the soil, because substrate के ऊपर तो definitely it will depend. If there is no substrate only, तो कौन करेगा? Denitrification होगा कैसे? अगर nitrate ही नहीं है तो denitrification कैसे होगा? So it is on substrate also. Then we have come to BNF. BNF again, please do not get confused with BNF and nitrification. Please don't. BNF is an important biochemical process associated with plants. Please focus. The BNF is carried out by certain bacteria, Actinomycetes, blue-green algae, fungi and yeast, which have ability to fix the atmospheric nitrogen in symbiosis with the plants or as free living organism. This line has been taken from old ISSS. You can go and read. It is exactly taken word by word from old ISSS. But majorly isme jo you have to remember, whichever has the nitrogenase enzyme, whichever organism has the nitrogenase enzyme, that can only do biological nitrogen fixation, because only it has, majorly it is prokaryotes only, which has the capability, this nitrogenase only has the capability to break the triple bond of nitrogen and fix it, because breaking this triple bond of nitrogen requires huge amount of energy. So biological nitrogen fixation, this is the symbiotic nitrogen fixation, this is the table, this is also very important. This has been made by Rohit. Again, I have to thank him for that. This is a very good table. So nodule forming rhizobium bacteria, soybean, alfalfa, pea, bean, all right. Then with Frankia, nodulated non-legumes. These are non-legumes, please remember, non-legumes. So these are Casuarina, Alnas, Myrica, Coriaria. All these are very important, extremely important. And finally, symbiotic association of Azolla, the aquatic fern, with Anabina azole, the blue-green algae, right? And then biological nitrogen fixation, non-symbiotic nitrogen fixation. These are the examples. ये यहाँ पे 3 में लिखा गया है. Why? I think you are understanding. First observed by Beijering. First observed by Beijering? I don't think so. BNF was first observed by Beijering. BNF was first observed by Boussingault, right? Beijering was the one who isolated, I think. As far as I remember, Beijering was the one who first isolated the नोड्यूल से राइजोबियम, और उसका नाम उन्होंने दिया था Bacillus radidicola. But the process of nitrogen fixation was observed by Boussingault, I think. Yes, Vipin, you are making me confused also, huh? Yes, Pavan, it was observed by Boussingault, but Beijering was the one who isolated the organism, the rhizobium, what we call rhizobium today. He isolated that from the plant nodules and he gave the name Bacillus radidicola. Huh? Remember that, that is important. Yahan pe, can you tell me what will be the captions of this? These things have been erased out, unfortunately. Can you tell me what will be the heading of this? Bacillus radidicola. I remember radidicola. Anyhow, Pavan or anyone, can you tell me the headlines of this? Why these three has been written alag alag? Non-symbiotic nitrogen fixation, so we know, but what will be the headline? So what will be the heading of the table that we have forgot? Or it is due to some technical glitch, I think, because yesterday night while I was preparing, I remember putting it. सिर्फ एरोबिक लिखने से नहीं होगा, you have to be more specific. Sorry sir, little bit confused. ऐसा confusion मत रखो यार. This will only cost you the rank. These are very critical things. Which is the middle one? Which is the middle one? Anyone? Vipin, please tell me what is the headline of the this and what is headline of this? Right? This is obligate aerobe, this is obligate anaerobe, and this is the facultative. This table is given very nicely in the nitrogen chapter of the old ISSS. Please read that. This box is very important. So biochemical pathway of nitrogen fixation. We have come to the biochemical pathway of nitrogen fixation. In this, there are lots of questions. I always told you. This reaction alone can have 3 questions, right? कौन सा 3 question है? Let's see. First is how many moles of ATP is required? Question number 1. What is the number of ATP molecules that is required? Question number 1. Question number 2. What is the number of electrons that is required? Question number 2. What is the number of H plus that is required? Question number 3. And how many moles of ammonia is formed in this process? This is question number 4. So in this simple equation, you can have 4 questions, which is equal to 4 into 4 equal to 16 marks. So this simple table has 4 potential questions. All right. In my MSc first year, when we had soil biology course, this question came, but our sir has asked for 1 mole of ammonium. For 1 mole of ammonia. Here it is 2. He asked for 1 mole of ammonia. What will be all this? So I think you are intelligent enough to say that everything will be divided by 2, definitely. So please remember this very thoroughly. This portion you have to remember very thoroughly. It is extremely important, this equation. Each and every part of this equation should be in your tip of your fingertip, right? Atmospheric N2 is reduced. So biological nitrogen fixation is a reduction process. That also you should remember. Reduced to NH3 in the presence of enzyme nitrogenase. See, everything is keyword here. Huge energy is required to break the triple bond between nitrogen atoms. This, just to break this bond, it is very difficult. In the N molecule is supplied by the host plant from photosynthesis. This is the process of reduction. You can remember the middle steps. Here I was telling hydrazine, you remember? N2H4, this hydrazine I was talking about, which is toxic to the microbes, right? Then finally hydroxylamine, and finally formation of ammonia. Then moving on, again we have missed the headline, but these are also called the cross inoculation groups. This is also a very important question, both in your MSc and in your JRF. Extremely important question. You have to remember, but remembering this is not that difficult, because if you remember this and if you remember the cover, you will see the scientific name of the crop is same. That is, the species will be same. This is also called Melilotus, right? Then trifoli is Trifolium alexandrium, right? Then Leguminosarum, P, you know, it is a leguminous plant. Then Japonicum, soybean. This is also Bradyrhizobium japonicum. Then Lupini, is lupines and fasciole is fasciolus. All right, these are very simple, but please remember this. This table you can read from here, or you can search in Google from any research paper. This is extremely important. You can expect at least one match the following, so definitely pakka, like it must have come by now. They have set the question and it must have come by now. All right, so nitrogen is done. I think nitrogen में और कुछ problem होने का तो chance नहीं है, but I will give you some, like covering everything in a 3-hour class, it's almost impossible, all of you know, but I will give you some tips for nitrogen. In the nitrogen, please read the processes very carefully, especially biological nitrogen fixation and nitrification. In the nitrification, in the old ISSS, please read all those variables what are written. Uska temperature range kitna hai, what is the pH range, in which pH it is ideal, what is the temperature range, and what is the moisture range, all those parts. Then please remember the name of the microbes, right? Nitrosomonas, Nitrobacter, Nitrosolobus, everything, whatever is there, please remember all those. And also in nitrogen, okay, yes, I forgot one part. Please remember these efficiencies, all right? This is also there, right? Can you tell me the full form of this? This one I forgot to add in the slide, but while I was preparing, then I remembered that I have to tell this also. So I think all of you know. Units are also very important. These units are also very, very important. You have to remember all the units. Is anyone there, or am I talking just alone? These are the different efficiency factors. These are the different efficiency factors of nitrogen. This is also there in old ISSS. If you see there, it is written in that right portion of the page. These are also very important. Yes, Shomik, you are perfectly correct. This is called the apparent recovery of nitrogen. This is agronomic efficiency of nitrogen. This is physiological, right? I think in 2025 or 24, this question came. They gave all the 4 options and they have asked, yes, physiology, yes, correct, Anil Jat, you are perfectly correct. So in 24 or 25, I cannot remember exactly, they have asked, I remember 1, 2, 3, 4 statements they have given, and they are like, please tell which one of these are the recovery efficiencies and which one are used. These once you will come in your MSc and you will do research, if you do on nitrogen, you will see these are very important, all right, very important. So इनका जो formula था, formula क्या था, वो भी लिख लेते हैं, है ना? So this is total uptake by control uptake by applied N fertilizer into 100, since this is a percentage, right? Agronomy we all know, agronomy deals with grain. So agronomy will definitely deal with grain. This is agronomic. Then finally, physiological will be all right. Sir, PN is written as production efficiency in old ISSS. No. It is physiological. ओल्ड ISSS में प्रोडक्शन एफिशिएंसी है क्या? प्रोडक्शन, हाँ मे बी हो सकता है. प्रोडक्शन एफिशिएंसी also मे बी हो सकता है. That is also there. I think in the 2025 question they have asked all the 4, right? They have asked apparent recovery, then agronomic, then physiological, and then production. So all 4 you have to remember. Old ISSS में जो 3 है, this you definitely read. Also I will say you please search in Google and see that, okay? And you please remember the units. So इसका मतलब I don't think समझाने का जरूरत है. It is written very clearly in old ISSS. If you see, this is total uptake from N fertilized plot. This is from control plot. This is the applied fertilizer. This is grain yield. This is applied fertilizer. This is grain yield. This is total uptake. All right. So what I was telling in nitrogen, these parts are very important. Read that very carefully, very nicely. and nitrogen or baki wahan se I don't think anything else is required. Like do not go for those extreme complex concepts, those are not required. And also jo nitrogen balance sheet hai last mein, that you can see once, but I think that will be more than enough. Okay, coming to phosphorus, we have already taken almost half, so let's see if we can complete. So functions of phosphorus, इसमें बोलने के तो कुछ है नहीं, I will not say anything, you all know component of enzyme, protein, adenosine, ATP and all. So this is also called, ATP is the energy currency, right? ATP is called the, ATP कहाँ है? ATP is called the energy currency of the cell. So this phosphorus is the, it is a key component of ATP, because ATP का full form ही है adenosine triphosphate. So without phosphorus there will be no ATP, there will be no energy currency, there will be no energy, right? Functions हो गया. Phosphorus deficiency, only the keywords, focus on the keywords, and again I will say read from treatise. These are very, very good in treatise. Read from treatise. So slow stunted purple coloration, this is very important. This is, you can see here, this is the like significant deficiency symptom of phosphorus. This is like the characteristic one. And excess का क्या होता है? Excess visual sign of ZN-FeMN deficiency. High plant P content may interfere with normal calcium nutrition and typical CA deficiency. These are all known facts. Phosphorus is 10th most, right? 10th most. यहाँ पे अगर 10th most आ ही गया तो एक के बाद एक सब लिख लेते हैं. OClFe Yes, so this is the 10th most, all right. Please remember all those. Sir, legumes can fix nitrogen was first observed in Boussingault and for nitrogen by and feed synthesized by Beijering. BNF was first observed by Beijering. Where have you got this? Like, can you tell me the source? Can you tell me the source? Like, first BNF was observed by Beijering. Where is it written? Beijering isolated and all, that is correct. But if there is any concrete source, you can tell me. Definitely, I will rectify myself. I also might have forgotten. So these things are just the values and data. Remember that. So phosphorus, inorganic phosphate in soil comprises of, we all know, iron and aluminum phosphate in acid soil and calcium phosphate in alkaline and calcareous soil, also in neutral soils also, right? It is written here. The former predominate in acidic soil, while later in neutral and alkaline soil. The soil organic P compounds may generally be classified into three groups, majorly inositol phosphate, comprising up to 60% of soil organic P. This is also very important. Please remember this statement, all right? This statement is very important. Inositol phosphate comprising up to 60% of soil organic P. This is very important. Organic P के अंदर भी, which is the most important, that will be inositol phosphate. Then nucleic acid and phospholipid, you all know. Please remember all these three. All these three are very important, and these two are also important, but these two are very easy to remember. Then we all know there are 4 pools. From these 4 pools, you can get lots of questions. You can get statement type question, you can get assertion reason type question, you can get direct question. Kitna sara pool hai. True false questions are very easy to set from this, because you have to remember these terms, right? Low accessibility, यहाँ के low को high कर देगा. They will give high accessibility and they will ask this. So you should be very thorough. This is extremely easy. There is nothing, but you should be thorough. All right. Which one is immediately accessible? Which is high accessible? Which is low? And this is very low. Then extractability low, very low. This is readily and this is in solution. So that is extracted already. And then the names of the pools: soil solution, surface adsorbed, strongly bonded, very strongly bonded. And also you can see the length of the arrows here. These arrows in two sides, it means equilibrium. Equilibrium means there is a forward reaction and there is a backward reaction. But this length of the arrow tells that this forward reaction is very fast, whereas this is smaller than this. That means this backward reaction is not that fast as the forward. Here you can see the backward reaction is very less than the forward reaction. So it means ये तो हो सकता है very easily, but ये होना थोड़ा मुश्किल है, ये नहीं होता है उतना easily. But here you can see soil solution and surface adsorbed, it is exactly equal, so it is in complete equilibrium. That means forward भी जितना easily हो सकता है, backward भी उतना easily हो सकता है, right? Then phosphate fixation. Phosphate fixation, we have finally come to phosphate fixation. Phosphate fixation is also called reversion, and it can be viewed as the conversion of soil solution P to insoluble compounds by the soil components, causing reduced availability to plants. P fixation is a combination of adsorption, chemisorption, and precipitation. This chemisorption is also called specific adsorption. दो टाइप का adsorption होता है, physisorption and chemisorption. Chemisorption is also called specific adsorption, whereas physisorption is non-specific adsorption. All right, it is significantly affected by soil pH. Because in neutral to alkaline pH, it gets adsorbed as tricalcium phosphate. We have already told this. While in acidic condition, it reacts with Fe and Al to form insoluble aluminium and iron phosphates. Aluminium phosphate is also called. What is the name of aluminium phosphate and iron phosphate? Can anyone tell? In acidic soil, what is the name of iron phosphate and aluminium phosphate? Sir, highly liable कौन सा है? Highly liable तो कोई टर्म नहीं होता है ना भाई. Liable तो कोई नहीं होता, labile होता है भाई. Highly labile, you can say this high accessibility. Can anyone tell what is the name? What is the name? Jarosite for Fe phosphate? No, Pawan. This is wrong. This is totally wrong. Yes, strengite and variscite. Nice, Vipin, nice. इसमें से कौन सा क्या है? स्ट्रेंगाइट क्या है और वेरिस्काइट क्या है? एल्यूमिनियम कौन सा है, एफी कौन सा है? स्ट्रेंगाइट एफी है, वेरिस्काइट एल्यूमिनियम है. सो व्हाई आर यू राइटिंग जेरोसाइट? एनीहाउ, कोई बात नहीं. हियर यू कैन सी इन न्यूट्रल टू अल्कालाइन सॉइल, you can see formation of tricalcium phosphate which is insoluble, whereas in acid soil it will form aluminium phosphate. Depending on the pH, it will form aluminium phosphate or iron phosphate, and also depending on the availability of these two. Right? Here I have taken this from this is from Tisdale. Yes, this is from Tisdale and Nelson. Tisdale का book से है ये. This is the mechanism of P adsorption to Al and Fe oxide surface, phosphate bonding through C. Here someone was telling कौन सा labile है, कौन सा non labile है. Jarosite is present in acid sulfate soil. Yes, perfect. Here you can see this is labile P, this is non labile P, right? So यहाँ पे this is the clay edge. You can see aluminium OH. Sorry, not the clay edge, but it is the oxide of aluminium. Here the phosphate comes. Phosphate का structure अगर हम देखेंगे तो what will be the structure? H2PO4 minus. This is the structure of phosphate, right? Then this O minus will attack here and it will form a bond. यहाँ से this O minus. So this O minus and this H2, it will move out. One water molecule will be expelled and it will form a single bond. When there is single bond, this is still in labile. But with time, with release of another water molecule कौन सा है? This H and this OH, this will also be released and there will be formation of two bonds. This is when this becomes bidentate, this becomes non-labile P and it is very difficult to make this available to plants. Whereas this is still labile and this is available to plants because इसमें एक ही bond है. यहाँ पे एक और very small information for you. How these phosphate compounds release energy. This bond is called pyrophosphate bond. This bond is having very high energy, just like triple bond of nitrogen. So with the breaking of this bond, this oxygen is, जब ये bond break होता है, huge amount of energy is released, and that energy is the source of the energy in ATP. So all these things only because here I want to tell you what is the ligand exchange. All right, I have been trying to tell this from the chemistry class only, but we will be very short, but you should definitely know what is ligand exchange. All right, so can anyone tell me what is a ligand? What is the exact meaning of a ligand? What is the English meaning of that? What is a ligand? Ligand का मतलब क्या है? Can anyone tell me? I can see very less number of people are available now, but anyhow, ligand satisfies the coordination of central cation. But ligand का मतलब क्या है? ligand का सीधा सीधा मतलब है electron donor. Okay, to lie or bind, that is chelate. Binding is related to chelate. Ligand is electron donor. What is a ligand? A ligand is a electron donor. Electron donor को बोलता है ligand. All right. Now what Pawan said, that is correct. ये जो electron donor है, suppose we will take the example of OH minus. This electron will be donated to any central cation to satisfy its primary valency and secondary valency. If it is an anionic ligand, that is, it is an anion, there is a minus charge, it will satisfy both. It will satisfy both primary valency and secondary valency of the central metal cation. Whereas if it is a neutral ligand, it can only satisfy the secondary valency, right? It can only satisfy the secondary valency. अब ये primary और secondary valency क्या है? You must have seen the writing of the coordination compounds. The theory of coordination compounds was given by Werner. You will see it is written like this. यहाँ पे -6 है, ये +3 है. So there is 3 minus. So this whole thing is 3 minus. उस 3 minus को balance करने के लिए say there will be Cl3. All right? Sorry. ये पूरा 3 minus को balance करने के लिए there will be K3 because minus charge है, balance करने के लिए plus लगेगा ना. This, whatever is inside the third bracket, whatever is inside the bracket, that is called secondary valency. And whatever is outside, that is called the primary valency. This oxidation state or this charge, this is the primary valency. Whereas secondary valency implies the structure. Last दिन we were reading, no, octahedron, tetrahedron. Secondary valency implies secondary, think of it like this. The central metal cation is sitting like this. Say this is the central metal cation. उसके बाहर there is one, say this is a VIP and this is the first layer of security. This is the secondary valency, all right. And outer this is the second layer of security. This is the primary valency. So first the secondary valency will be satisfied, जिसके वजह से the electron का जितना भी orbital है, all the orbitals will be fulfilled and it will make a compound. वो compound बनाने के बाद whatever charge is remaining, that charge will be satisfied by some other ion, that is the primary valency. All right, that is the primary valency. So this is the खेल of primary valency and secondary valency. When that is a neutral ligand के पास you can understand charge balance करने के लिए उसके पास तो charge है ही नहीं. H2O के पास क्या capacity है to balance the charge? So it cannot satisfy the primary valency, but it can satisfy the secondary valency. But in case of if the ligand is anionic ligand के पास तो charge है. When it is anionic ligand, उसके पास तो charge है. So when there is charge, it can satisfy both the primary valency and the secondary valency. All right, I think it is clear by now. And why it is called ligand exchange? Because that central metal cation, it will have bond with some ligand before, usko hata ke the new ligand is coming. So it is like a substitute. It is like exchange. OH को हटा के phosphate घुस रहा है. So that is called ligand exchange. Exchange हो रहा है. OH के साथ phosphate का exchange. All right. So that is ligand exchange. और यहाँ पे जो ये specific adsorption होता है, when it is a physical adsorption, when it is non-specific, तो उसमें सिर्फ इलेक्ट्रोस्टैटिक इंटरेक्शन होता है. सो उसमें एब्जॉर्प्शन में जितना एनर्जी रिलीज होगा उसको डिसॉर्ब करने में उतना ही एनर्जी लगेगा. बट इन द केस ऑफ स्पेसिफिक एब्जॉर्प्शन, दिस एनर्जी इज अनइक्वल. दैट इज व्हेन द एब्जॉर्प्शन विल हैपन, the energy that will be released with the adsorption, that will not be equal to the energy that is released to dissolve that same molecule. मतलब bond एक बार form हो गया, then due to some synergistic interaction, that bond will be very strong and desorption will require a lot of high energy. This process is called, this process is also there in soil water drying and wetting में. That same process also occurs here. That is, the energy will be different in this case, which is required in adsorption and in desorption. So this process is also called hysteresis. All right. So this hysteresis is there in case of soil water also. You all know drying and wetting curve. But again, in this case of specific adsorption also, there is hysteresis. यहाँ पे hysteresis का मतलब है the energy that is required to in adsorption and in desorption, that is not the same. All right. We have spoken a lot about this. Now let's move on. This is also again, you all know, mineralization and immobilization, the same thing. Mineralization और immobilization का definition तो change नहीं होता है, it is same. Ink bottle effect, अरे यार अभी soil water में क्यों जा रहे हो? Soil water तो हो गया है. In the context of specific adsorption, I am telling, did you understand? What is hysteresis in the context of specific adsorption, in the context of chemisorption? ये ligand exchange जब होगा, so during the formation of the bond, the energy that is released, that will not be equal to the energy that will be released to break the same bond. All right. The ligand exchange is a very important process for phosphate fixation. Due to this ligand exchange only, there is widespread phosphate deficiencies and phosphate is very less available to plants, and usme like it takes a lot of chemistry and it takes a lot of effort to make that phosphate available to plants. All right. Pawan, did you understand the hysteresis in context of specific adsorption? First time learned. Arey, this is also in old ISSS. This is also written in old ISSS. During specific adsorption, the energy that is released during adsorption and the energy that is you need to supply during desorption are different. उसमें ज़्यादा energy देना होता है. That is why it is called hysteresis. All right. So this is also in old ISSS. यार पढ़ो यार. कोई बात नहीं, अभी पढ़ने का ज़रूरत नहीं है. Now it's time to revise and crack the exam and get a rank within top 10 definitely. So net here this is important. CP ratio below 200:1. Net mineralization of organic P, while net immobilization is above 300:1. These values are not sacrosanct. I will tell you, these values are not exact or accurate. Examiner जो है, from wherever he is setting the question, it will be up to him. So एक एक किताब में you will find this different value. Somewhere it will be written some. So please have a wide range of idea, like something nearer to this you should mark. All right. So please have an idea, faint idea like that. Analysis of phosphorus. In nitrogen, we have not covered the analysis part. Analysis part will be covered by Rohit in the upcoming classes, instrumentation. So please be very thorough with analysis also. Here I have specifically added this for you. So most widely used methods, we all know there are two methods. Olsen method is 0.5 molar sodium bicarbonate at pH 8.5. Everything should be in the tip of your lips, whatever I am saying here. Olsen et al. 1954. And 0.03 normal NH4F, 0.025 normal HCl, Bray and Kudz. This is also called Bray and Kudz P1, 1945. All right. Here, ये जो normality है, इसको normality ही लिखना पड़ेगा, because in 2024 JRF they have asked it with normality and molarity. Here you can see NH4F is having N factor of 1. So इसका molarity is equal to normality. But still the students who have given the answer as molarity, NTA has not given the marks. So NTA तो boss है, we all know. So whatever is written in the book, whatever is written in the ISSS, वही तुमको mark करके आना पड़ेगा. in that case you can challenge, लेकिन challenge से भी कुछ नहीं होता, trust me. Last time in SRF I challenged 4 questions जिसमें से एक भी नहीं लिया वो लोग, all with sources of ISSS, but I don't know what they think or what they do. Anyhow, so please remember all these values, and here you have to remember it as normality only, 0.03 normal and 0.025 normal, and who gave it. The former extractant यानी कि olsen is generally used for neutral and alkaline soils. This also you know because यहाँ पे sodium bicarbonate है. This is specifically designed to stop the dissolution of calcium carbonate, है ना? And then while latter is used in acid soils, pH अगर 6.5 से नीचे है तो we will use Bray curds. The concentration of P in soil solution is about this much with an average of this much. This is the range. This is the critical limit. Now I will test you guys. हाँ, यहाँ पे लिखा है देखो, categorized as low, medium and high. For olsen the critical limit is 10 to 25, right? Less than 10 is less, more than 25 is high. Can anyone tell me what is the critical limit for Bray curds? Please do not tell it is same, because अगर same होता तो मैं नहीं बोलता. हाँ, Bray 2 method is there, no? Bray curds P2. It is the nice table is given in ISSS. Old ISSS का जो table है उसमें देख लेना. In Bray curds P2, the only difference is this. The only difference is this HCl. यहाँ पे 0.025 है, that is 0.1 normal. HCl का strength बढ़ जाता है और उसका pH भी घट जाता है, right? Bray curds P2 का. And P1 is 0.025, in P2 it is 0.1 normal HCl. Read that table very thoroughly. So can you tell me what is the limits for Bray curds method? Olsen तो सबको पता है 10 to 25. Please don't say it is the same, क्योंकि अगर same होता तो मैं पूछता नहीं, है ना? $35, $60 something लिखने से पवन कैसे होगा? It is there in new ISSS, right? It is there in new ISSS. New ISSS का वो table, I think you have not read that. It is in that chapter written by Dr. B.S. Dwivedi, Soil Fertility Evaluation का second chapter, Soil Fertilizer Recommendation something नाम है. Please remember this, all right? This is also very important. The answer is 34 to 68. You are very close, 35 to 60 something. You are very close. Yes, Pawan, that is very impressive. But Bray and Curds का limit है 34 to 68. ये भी आ सकता है ना? This also might come because we all read only 10 to 25 only. So 34 to 68, याद रखना. So P use efficiency can be increased by, we all know this. I think there is no point discussing all this. Time of application, method, liming, treatment, role of mycorrhiza, role of P. This point is important. P solubilizing microorganisms, also called PSM. PSM का जो example है, you have to remember the examples. यहाँ पे examples I have not given because examples I know you all know. And moving on. These have been taken specifically for you. This also has been compiled by Rohit, our another mentor. So this you can see. This line I was already telling. This is very important. This is also very important. P deficiency is more severe in acid soils. You can see here. P fixed is held 5 times more bonding energy in acid soil than calcareous soil. Then it is controlled by capacity and intensity factors. इसके बारे में हम डिटेल में बात करेंगे in potassium. Definitely, all of you know. P is difficult soluble with compounds like Fe and Al at low pH, Ca at high pH. Intensity, it is the concentration in soil solution. Capacity, it is the capability to supply. This table is extremely important. Yes, please remember this very thoroughly. I was telling also in the time of telling Schofield's ratio law. Schofield's ratio law का सबसे बेहतरीन, सबसे the best application of Schofield's ratio law is lime potential, right? This phosphate potential also. From this only last year SRF question came, the name of the scientists. So remember, phosphate potential was given by Schofield alone and lime potential was given by Schofield and Taylor. 1955. You have to remember the year, you have to remember the name of the scientists as well. All right. So यहाँ पे, and this is also जहाँ से question आता है, हाँ yes yes, Schofield and Taylor 1955 भी लिख दो यार, मजा आ जाएगा फिर. So this is also a question. This is also a question, that is why it has been written. Higher value of phosphate potential means low PO4 minus. यहाँ पे बहुत ज़्यादा confusion होता है. You get highly confused. That's why. Whereas for lime potential, higher value, greater will be the activity of calcium hydroxide in solution. So ये दोनों opposite है. If you see, like conceptually, these two are opposite. Phosphate potential जितना ज़्यादा है, उतना low PO4 minus concentration है. But lime potential जितना ज़्यादा है, उतना activity of CaOH2 minus ज़्यादा है. What is the reason for this? The reason is, you can see यहाँ पे जो these two signs, right? pH, we know pH is minus log. So P जब minus log लग रहा है, so plus minus it will be ulta. But here in case it will be minus minus, it will be ulta. It will be opposite. That is why these are very important. Again, I am stressing, I cannot stress enough. From this you can get all the statement type question, assertion reason type question, right? Phosphate potential में higher value indicates what? Lime potential में higher value indicates what? This you have to remember. And then these two are okay. You can go through it if you get the PPT. Then functions of potassium, we have come to potassium. Nitrogen और phosphorus खत्म हो गया. Phosphorus में specifically you should read the fixation part. Phosphorus में you should specifically read the fixation part and the adsorption part. Remember, when the concentration of phosphate is lower, तब adsorption होगा. When it is higher, तब precipitation होगा. This is common sense only. When it is low, it will only be adsorbed. When it is high, it will be precipitated. That is number one. Please read all the fixation parts very thoroughly in phosphorus. Again, these are the tips I am giving you for the exam. Please read the fixation parts. जहाँ पे in calcareous soil कब octacalcium होता है, कब tricalcium होता है, कब monocalcium, dicalcium, how it flows, and which one is soluble, which one is insoluble, that you should remember. Then you have to remember that graph also. That graph also I have not included here, but that is very easy. You know all these two, right? This is the, यहाँ पे जाके solubility बढ़ रहा है, मतलब this is the AL-Fe phosphate and this is the apatite, like that is the Ca phosphate, and this place is having the highest availability of phosphorus. I already told it is pH dependent, so उसको अच्छे से पढ़ना. Then after that, in phosphorus, what else you can read? You have to read that phosphorus solubilizing microorganisms. That portion also you have to read very thoroughly. And again, you can go for phosphorus में all the pools, the 4 pools. And then Q by I relation is also not that important in case of phosphorus, but you can read that also. Who gave that? What is the name? And there the capacity factor, the supply parameter, those terms are there, supply parameters and all. I have not included here, but you can read that. So these portions you can read, and I think you are good to go with phosphorus. वहाँ से और कुछ question आता है क्या? नहीं आता है. But this fixation, it carries lots of question, lots of ligand exchange, specific adsorption, precipitation, adsorption, कहाँ पे, how it is getting fixed, why is phosphorus not available, right? All these are very important. Now coming to potassium. Potassium का function, again I will not say anything, you all know. Turgor pressure of cell, opening and closing of stomata, we all know this, very good. Accumulation and translocation of newly formed carbohydrates. Then inka supply, it increases root growth and improve drought tolerance. This part is a question that has come at least maybe 7-8 times in last 5-6 years. So this statement you should remember very thoroughly. Activates large number of enzyme greater than 60 by way of exposing the active reaction site. All right. यहाँ पे भी एक confusion होता है, because in one chapter it is written more than 80, in another one it is written more than 60. But if you see new ISSS, it is written more than 60. So you have to go with more than 60 only. Then it neutralizes organic anions and maintains the pH. It reduces lodging. It increases crop quality and winter hardiness and imparts disease resistance. This slide is extremely beautiful. If you can see, only the keywords have been highlighted. And just before the exam, if you read this once, not even the whole slide, just these words, you will have no problem, right? Moving on, similar deficiency symptom, edges. This is the keyword. Then appear burned, scorching. These two are the keyword. Then lodging, sensitive to disease infestation, that is okay. Fruit and seed will be poor quality. Then hidden hunger. Hidden hunger is associated. Luxury consumption is also associated. That we already told. Luxury consumption. The excess symptom is typical Mg and Ca deficiency, because it will have interaction effect, right? Interaction effect of the cations. Then potassium is often called potash. It came from that same word only. Potash se potassium aaya hai. That is why it is called potash. It constitutes 2.5 of the 7th most abundant, that you already know. I wrote all those. Potassium is present in igneous, sediment, and metamorphic rocks. Okay, fine. These are not needed. Major K bearing minerals. This you can read. Mica and feldspar, right? In this, let's see whether you remember the chemistry or not. Biotite and muscovite, which is more weatherable? Can you tell? Which is more weatherable and which will release more potassium, biotite or muscovite? Biotite or muscovite? Biotite more weatherable. Can you tell why? Just one or two words. You do not have to explain. Can you tell why? Due to presence of ferromagnesium, yes. And another related to clay mineralogy, another thing which I explained in the chemistry marathon, if you remember, some structure, ditrigonal cavity happens because of which process? What is the process? It is trioctahedral, yes. Again, you are correct. What happens? What is the reason? There is one specific process which results in formation of ditrigonal cavity, which holds the potassium very highly. That results in less weathering in case of dioctahedral, that is muscovite, whereas in case of biotite, it is the weathering is more. It is the process of tetrahedral rotation. That's why less bending in tetrahedral octahedral. Perfect, very good. Did you attend the last chemistry marathon class, or did you know this before? Please let me know. Okay, anyhow, the K-bearing primary minerals, mica and feldspar, when exposed to weathering agents, transform to other secondary minerals such as vermiculite, smectite, kaolinite, and release potassium. This is also very important. In new ISSS, in the SC Datta Sir's chapter, Soil Mineralogy and Chemistry, you will find there is a specific place for mica weathering. That is also very important. Please read that part also. Then illite, weathered mica, vermiculite and smectite fix K in greater extent than 1:1 minerals. That is very normal, common sense only. Under acidic condition, K fixing capacity reduced by presence of Al3 plus and Al hydroxide cation due to competition for inner layer exchange position. Order of competitive ability is NH4, Ca2, Mg2 and Na plus. These are all general informations only. You should remember that. Yes, this one is the clay minerals. I didn't the last class, by the way, that was nice explanation. Thank you so much, Pawan. So this is the mica and illite, vermiculite and smectite. Here you can see the CEC, and here you can see the layer charge. The layer charge is decreasing as we are going towards the right side. This is that example of mica weathering which I was telling. Here in mica and illite, you can see the two layers are closed, and here the K plus is there. Then as it is going vermiculite, the C axis spacing is increasing. This is getting open. Water, Ca2 plus, water, these are entering, and potassium is getting released. Then with the formation of smectite, you can see it is getting more apart, the C axis spacing, and these are water and calcium, everything is inside, and the K plus has been released. So you can see the layer charge is decreasing. With decreasing of layer charge, the layers are opening very easily, right? 4 forms of K in decreasing order of availability. Once released from mineral structure, K ions move to soil solution. This is fine. This is called solution K. A part of released potassium is held around negatively charged particles. That is called exchangeable K. In potassium also, you know, there are 4 pools. That is written here, 4 forms. So there are 4 pools only. I think there is nothing much to discuss there. There is one question in this which I would like to ask. Can you tell me, under wet condition and under dry condition, which mineral will fix potassium? Which mineral can fix, which clay mineral can fix potassium? Yes. Among, I will make the question more direct. Vermiculite and montmorillonite, and there are two conditions. Okay, so can you tell me which can fix potassium in what? Montmorillonite in dry, vermiculite in both. Montmorillonite only in dry, but vermiculite in both. Exact. That is a perfect answer, Pawan. That is very impressive. Yes. Now, ऐसा क्यों है? I will just give one line explanation. Vermiculite has more layer charge, and we know potassium or all the ions in that sense in soil, that is hydrated, that is having a hydration shell. So the unhydrated diameter of potassium, that is similar to the diameter of the ditrigonal cavity. So fixation होने के लिए potassium should be unhydrated. Hydrated potassium cannot be fixed, because with the inclusion of hydration shell it becomes very huge, large. So ये जो hydration shell है, you have to strip this off. Stripping this hydration shell off, it requires higher layer charge. Vermiculite has higher layer charge. So higher layer charge. So in both wet and dry, it has the capacity to strip off the hydration shell of the potassium and fix it inside. Whereas montmorillonite with low layer charge, it can fix in dry condition when there is no water. But in case there is presence of water, it cannot fix potassium because it has low layer charge and yet it cannot strip off. Like ये stripping off क्या होता है? There are two layers, दोनों लेयर के बीच में इलेक्ट्रिक फील्ड है, बीच में you are putting one, दोनों highly negative है, बीच में you are putting a positive ion. So layer charge should be strong enough so that when this ion is entering, it will release the hydration shell, go inside, and the two layers will be collapsed, right? So here also you have to remember only the key points. So there are generally three types of binding position, all of you know. Planar position, P position on outside surface, then edge position, that is the E position, and inner or I position, that is inside in the interlayer space of clay colloid. The exchange site in P position are very non-specific. अभी बहुत देर से we were talking about specific adsorption and non-specific adsorption. So definitely mineral का जो outer side है वहाँ पे it will be non-specific only. It will just form electrostatic attraction and it will go. Non-specific will have no hysteresis. It will have the same energy expenditure in both. The third pool of soil K is the non-exchangeable K. This pool of K occupies internal position of clay sheet as well as hexagonal cavities within interlayer space of certain minerals such as illite, जिसके बारे में we have talked in detail in the chemistry marathon class. Here also other cations are attracted equally by, see, this is non-specific because other cations are attracted equally by these exchange sites, while exchange sites at E and I positions have high K specificity. यहाँ से एक question बहुत बार आता है, I have seen it many times in the previous year questions, that which is having the highest specificity, and that is a common sense only, that will be I, right? Here the term total or mineral K is frequently used to describe much larger fraction of K that remains entrapped within clay structure, right? Now coming to the quantity intensity factor, this also intensity factor is a measure of K in soil solution that is immediately available for absorption by plants. Since this absorption is influenced by the activity of other cations in soil solution, that is, there is a competition between other cations. That is why potassium activity ratio is used in case of potassium concentration. That is used in place of K concentration alone to indicate the intensity factor. This is the graph. This is the Q by I plot. This Q by I, this slope of this graph, it tells the PBC, potential buffering capacity, all right. This graph is also very, very important. Read this graph very thoroughly from old ISSS. Here you have to, below the graph, you will see the explanation of all this. You have to remember all this, right? Like this S, exchangeable Ks, this part is the specifically adsorbed K, this part, when this line is becoming non-linear. If that is becoming linear, then this part is the exchangeable K, which is non-specific. Then this part ARK0, it is the equilibrium activity ratio. यहाँ से भी question आता है, what is the meaning of this? What is the meaning of ARK0? This question I have seen at least 2 or 3 times in previous year papers. It means, what is the meaning of this ARK0? It indicates the inherent capacity of the soil to supply potassium, right? It is the inherent capacity of the supply to soil potassium, that is the equilibrium activity ratio, ARK0, right? ये जो जितना भी है, please read very thoroughly. यहाँ से question आता है, read it from old ISSS, read it from new ISSS as well. New ISSS का जो potassium chapter है, written by Saroj Kumar Sannal and Kaushik Mojumdar, that chapter is also very important, very nicely written. If you read it once, everything will be clear. वहाँ पे भी जो graph है, read that. All right. So quantity factor is a measure of capacity of soil to maintain level of K. We all know this. This capacity is mainly due to exchangeable K. This also we know. Here it is the measurement. Measurement of available K is due by neutral normal ammonium acetate. Neutral normal का मतलब है 1 normal at pH 7. pH 7 means neutral. Normal means 1 normal. In 1:5 soil solution ratio for 5 minutes. This all you know. Here soils are classified as low, medium, high, and the critical limits are 120 to 280. We have talked extensively about the critical limit of both phosphorus and potassium, लेकिन nitrogen का बात हमने नहीं किया था. So nitrogen also, I think all of you know, you should know, it is 280 to 560 in case of available nitrogen by Subbaiah and Ashija. Subbaiah and Ashija, 1956, right? This will be covered in detail by Rohit in the upcoming classes. So these are the potassium fertilizers in soil. This we will see later in the next part, part 2, not today. But here you can see nothing much is written. Kitna K hai, kitna K2O hai. Please remember the K and K2O wala factor, and also see the question very thoroughly whether they are asking K or K2O. And in that case, if there is any option which is equal to the K, then go for that only. Then this is MOP, this is SOP, you all know. Potassium sulfate is preferred source for tobacco, potato, citrus and all. Due to its lower salt index, we know KCl will decrease the burning quality of tobacco and also the starch quality of potato. Then potassium nitrate is another source. Potassium nitrate is typically made by reacting this. Okay, fine. There is some information about Langbainite. This also you can read if you read the PPT. Then you can see phosphorus and potassium are the two major plant nutrients. Plants require these two nutrients in large quantities for completion of their life cycle. Plant availability of P and K are governed by their unique dynamics, largely due to differing ionic forms. Okay, this is the summary of what we read. Factors affecting ये सब I don't think बोलने का जरूरत है. You can just go through this once and you will know. Soil texture, clay mineralogy, depth, pH, liming, freezing and thawing, wetting and drying. Clay mineralogy में this is very important. This is very important. Fixation का भी एक there is one series that also you should read. And soil texture, finer the texture, more is the available and non-exchangeable K. This is also fine. Interaction of potassium with other nutrients. This we have added specifically for your help. This is called the VH effect, right? So what is VH effect? Named after FG VH. This is also important. VH effect किसके नाम से नामांकित है? It says that higher Ca concentration in the outer solution either enhances the uptake of K or reduces the loss of K. Hence, the tissue K concentration increases. So, higher Ca concentration will either increase the uptake of K or it will reduce the loss of K. Thereby, final जो उसका product होगा, that would be increase in the concentration of K. So, high potassium fertilization can decrease the availability of magnesium, जिसके वजह से we know what happens, grass tetany disease. This is also very important. Low content of Mg and Ca in forage can affect animal by producing low blood serum, that is called grass tetany disease. Addition of K result in lower concentration of Ca or Mg regardless of the crop grown. Then we are coming to the secondary nutrients. यहाँ तक पोटेशियम हो गया. पोटेशियम is easy. पोटेशियम में ज़्यादा कुछ पढ़ने का है नहीं. But you should remember here I have added one slide. Sorry. Here I have added the points to remember for you. These are the points to remember जहाँ से question आता ही आता है. So the lattice hole theory was given by Page and Weber 1940. ये याद होना चाहिए एकदम year के साथ. Then step K and constant rate K. Even if you don't know the theory, that is very fine, no problem in that, but you have to remember it is Halox and you have to remember it is 1956 because it will come in match the following. Then Q by I relation of potassium was given by Beckett 1964. This also you should remember definitely. Mineral nutrition of higher plants. This book is like the Bible of all the mineral nutrition books and it is written by Marshnar. This also comes in question because they will ask the name of the book and the author in match the following. So all these four are according to me very important, or in char mein se at least one or two you are getting in this year's JRF also. You can be sure of that. Okay. So secondary nutrients in soil, we know Ca, Mg and S. These are the secondary nutrients because their requirements are quantitatively less than those of primary nutrients, और इनके लिए कोई अलग से फर्टिलाइजर नहीं है. जो प्राइमरी न्यूट्रिएंट का फर्टिलाइजर है उन्हीं के साथ इनका भी डेफिशिएंसी ठीक हो जाता है. सो दिस यू कैन रीड. Then importance in plant and soil system, calcium and magnesium are strongly electrophilant, most abundant cations occupying this. Okay, I don't think anything is needed here. This is an important part. This is not in ISSS. We have added this alag se. Yes, Pawan, you were correct. Quantity intensity factor given by Beckett and Tinker. It was in 1964, right? So calmodulin, it is a Ca binding protein present in all eukaryotic cells that serve as primary intracellular receptor of calcium. This protein has 4 calcium sites. All right, you can remember this information. Maybe they will not ask anything deep from this, but maybe you can find this word in the exam in match the following or anything. The metalloenzyme amylase is very important for starch. Has calcium as metal. Calcium is major cation in middle lamella of cell walls. This is also important, of which calcium pectate is the principal constituent. All right, these are very known facts. Then these are magnesium is essential constituent of chlorophyll. It is the middle atom. High proportion of total Mg ion is involved in regulation of cellular pH, cation anion balance. Sulfur occur as sulfides in igneous rocks. Okay, this ratio is very important. That's why this has been highlighted. If you read this PPT, you can go through this, no problem. Sulfur deficiency occurs in this type of soil. Fine. This one. This one is very important statement. Calcium is transported to roots by mass flow, both calcium and magnesium, right? Then the other information you can read here, there is nothing. These are the hydration shells. You can see how calcium stays in the soil system. Actually, all the ions stay like this in the soil system. Moving on, then lime-induced iron chlorosis, we know it is the inability of roots to metabolize iron in calcareous soil due to excess presence of bicarbonate. Calcium की वजह से lime-induced epichlorosis. This I have seen questions at least 3-4 times in the last 5 years. This is very important, extremely important. Lime-induced chlorosis में अगर lime-induced को हटा दिया तो epichlorosis किसके वजह से होता है? You have to answer calcium, right? Then magnesium is also regulation of cellular pH. Non-exchangeable form has higher than water. Okay, fine. Nothing to read here. High amount of aluminium in plants causes grass tetany in cattle due to magnesium deficiency, right? Also called hypomagnesemia. This we saw in potassium also, right? Ratio of Ca and Mg must not exceed 7:1. It stabilizes ribosomal particles. K into Mg show antagonistic effect. This we talked about extensively in the potassium portion. This is also a reason of this disease, not a problem. Then fixation of Ca, Mg is greater in chlorite and vermiculite because this we have seen in the last class of chemistry marathon, right? Because vermiculite and chlorite के अंदर magnesium ज़्यादा रहता है. In chlorite there is a magnesium sheet called the brucite, and vermiculite also contains magnesium due to isomorpha substitution, right? Then ratio of K is to Mg should be this, and for vegetable and sugar beet it should be this. Then coming to sulfur and sulfur chemistry, is very similar to that of nitrogen. All right, दोनों बहुत ज़्यादा similar है, दोनों का deficiency symptom भी very similar, बहुत ज़्यादा similar है. So similar क्यों बोल रहा हूँ? Because nitrogen also exists in a lot of oxidation state from -3 to +5. In case of sulfur also, it can go from -2 to +6, है ना? So these are very similar. And here also you can see organic form of sulfur is 80 to 90%. Organic form of nitrogen was also 95 to 98%, है ना? Biologically important desk compounds thiamine, biotin and glutathione. These are very important. Biomolecules, I think all of you are very thorough with your biomolecule. Biomolecule से बहुत question आता है. विटामिन का जो टेबल है वो पूरा का पूरा याद होना चाहिए along with the name, chemical names. कौन वाटर soluble है, कौन फैट soluble है, with the chemical names. That is a very important source of question and many question might come, right? 1:1 clay adsorb SO4 2- greater than. This is a very common sense because of anion exchange capacity. AEC is there. S oxidizers are heterobacillus, obligate autotrophic bacteria, thiobacillus, photolithotropes, greenhouse bacteria, chlorobium, purple S bacteria, chromatium. CS ratio less than 200:1 is mineralization. All right. ADE के fat soluble, BC water soluble. ये तो भाई easy है. But B का जो parts है, B1, B2, B3, all the chemical names you should remember. All the chemical names. I have seen question. Thiamine, which is thiamine, which is cyanocobalamin, right? वो पूरा का पूरा याद होना चाहिए. Sources of secondary nutrients. This is, I don't think this is any important. You can just रखना पड़ता है इसीलिए रख दिया. But you can see there is nothing to tell. Then here in the sources, these are very important, right? These are very important. The names of the minerals and their chemical formula, right? Chalcopyrite, marcasite, sphalerite, gypsum, cobaltite and epsomite. Epsomite, मुझे जितना याद है, it was 7H2, right? Sorry for that. Then removal of secondary nutrients, legumes and root crops remove more Ca than cereals and other grasses. That's true. This is also very important. Among families of crop plants, requirement of sulfur increases in the order Gramineae, Leguminosae, Crucifera, right? S requirement of oilseeds also follow the order Crucifer, Sesame, Sunflower, Legume and Linseed. Legume is not a oilseed, but it has been put, all right? So crucifers jo hai, this Crucifera, it requires huge amount of sulfur. I think you all know that. This is a general agriculture question from Nimrat Sunda. The critical limits are very important for each and all of the nutrients. You have to remember the critical limits: nitrogen, phosphorus, potassium, calcium, magnesium, sulfur, and also the micronutrients. Sorry to say that, but you have to remember. All right. This is okay. Soils containing 10 centimole, less than 4 to 15% of CEC occupied by Mg are considered deficient. Less than 25% is considered calcium deficient. Here, critical limit of CaCl2 0.15% CaCl2 extractable sulfur is 10 ppm. This is a very important question. This comes in many exams, and also I remember this came in our MSc first year exam also. So 10 ppm. Remember this 10 ppm. If they are asking this in kg per hectare, can you tell me what is the conversion factor between ppm and kg per hectare? You should definitely know this. You are fourth year students giving JRF, will be coming to IRI very soon. So tell me what is the factor of change between ppm and kg per hectare. If they ask it in kg per hectare, what will be the critical limit? Can you tell me? What will be the critical limit? Multiply with what? Multiply with 10,000. Wow. Totally wrong. You are totally wrong. 22.4. Acha, 22.4 is it? Yes, correct. You have to multiply with 2.24. But in most of the questions you will see they will not consider at 2.24, they will consider as 2 only, right? So if it is 10 ppm, it is 20 kg per hectare. इसका conversion तो very easy है. What is the problem? 2.24 comes from what? 2.24 into 10 to the power 6 kg. It is the weight of furrow slice of soil, right? It is the weight of the 15 centimeter soil. वहीं से आता है. From that only it comes. ppm means 1 by 10 to the power 6. I am telling repeatedly, parts per million. In 1 million, how much parts is there? So here also it is 2.24 into 10 to the power 6. This is only million only. So this will act as the million. In 1 hectare, this is the weight. So ppm is a ratio, right? ppm is a ratio. So it will be 1 kg in 2.24 into 10 to the power 6 kg. So this 1 by 10 to the power 6 is nothing but ppm. So it will be 2.24 into ppm. That will give you the kg per hectare. It is that simple. You should be very thorough with this. So mineralization of sulfur compounds, this is also very easy. You can read it. There is nothing to explain. Optimum temperature itna hona chahiye, moisture level itna hona chahiye. Conversion of organic S to sulfate ion is oxidation. S in the soil is associated and the CS ratio is 140:1. Right? This is the sulfur cycle. This has been made using AI, as you can see. But the sulfur cycle of the old ICARS, that is also very, very, very good. You can read that. That will be more than enough. Then reduction oxidation reactions of sulfur. Here I was telling you, sulfur stays from -2 to +6. It has a wide range of reduction and oxidation state. It has a wide range of oxidation states, and how it transforms, it is given here. The reactions are biochemical in nature and are mediated by autotrophic bacteria belonging to Thiobacillus. Nitrate and sulfate are reduced and utilized by organisms like Disulfovibrio and Disulfotomaculum. In the process, these ions are reduced to nitrites, nitrous oxides, sulfides and sulfides. Because these are anaerobic, so they will use sulfate as the electron acceptor. Oxygen का काम aerobic के case में, for us also, what is the role of oxygen in respiration? Oxygen is the terminal electron acceptor. So when there is not oxygen, the microbes will use any other compound which is having a high oxidation state as the electron acceptor. As simple as that. So acid sulfate soils or cat clays are locally known as kari. It is salt tolerant rice varieties like pokali can be grown under such soil. This is just one page of acid sulfate soil. Acid sulfate soil has been already covered by Rohit. You can see in the video of problematic soil. There you can read it. Here soils which are acidic in nature, use of such sulfur containing minerals is not recommended. This may increase soil acidity in long run due to the formation of H2SO4, right? But in case of alkaline or calcareous soil, this might prove helpful. There is nothing to say. Alright, we have come to the final part of today. We have half an hour left almost. I think we will complete micronutrients, not a problem. Micronutrients are also called trace elements. मैं पहले स्लाइड में बोला था ट्रेस का मतलब होता है कम, छोटा, less. So micronutrients are the less. These are iron, manganese. You all know which is the micronutrients. Molybdenum is also called ultra micronutrient, right? Amongst 8 micronutrients, content of Fe in soil as well as in plants is highest and sometimes is higher than even P and S. This is very important. Here I will tell you a story. When I was in class 8, when I was in class 7, at that time when we used to read, I myself have read iron as macronutrient, you know. But after that it was changed to micronutrient and iron was taken as the threshold. Lesser than iron, micro, more than iron will be macro, and iron was included into the micronutrient only, right? Of the 8 micronutrients, Fe, Mn, Zn, Cu, Ni behave like cations and B, MO and Cl behave like anions, right? This is all very simple. We have all talked about this in before only. Source of micronutrients, we all know सारे mineral का source एक ही है. Primary rocks have higher content of this, whereas sedimentary rock, this is very important, this statement. This statement is very question worthy, and please, if you have pen and paper, please note this down. This statement has been taken directly from the old ICARS. अगर note नहीं भी करना है, old ICARS में पढ़ लेना. This statement is very, very important. Primary rocks have higher content of manganese, cobalt, nickel, copper and zinc, whereas sedimentary rocks are rich in B and MO. I myself have faced this question in my same exams in MSc, where they have asked which rocks are rich in B and MO, and in another question they asked sedimentary rocks are rich in what. So sedimentary rocks B and MO, then primary rocks are Mn, Co, Ni, Cu and Zn. All right, ये याद होना चाहिए. Primary rocks, that is igneous rocks. Please remember this. They are present in soil mainly as their oxide, sulfide and silicates. The position, this is also very important. The position of a trace element in mineral framework depends on its radius. Whether its abundance in mineral is decided by its chemical affinity. All these lines are from ICCS introduction part only of micronutrients chapter. If you open the micronutrient chapter, पहला ही पेज में ये सारा मिल जाएगा. Please read it very thoroughly. These are very, very important. Micronutrient is a highly scoring area. There are only set of questions. Those questions only will come and you will get full marks. Don't worry. This value of electronegativity on Pauling scale, this is also taken directly from old ICCS. If you remember, all these are very important. All right, याद होना चाहिए. The fate of released trace elements during weathering depends upon the ionic potential. All these lines have been taken only from old ICCS, which are important. इसको बस एक बार देख लेना. Done. There will be no problem. And potential, ionic potential is nothing but it is the charge by radius. All right, we all know this. This ionic potential is responsible for the, you all know, the dispersing power also. The dispersing power of the element in clay colloid, that also depends on the ionic potential only, because it is not only depend on charge, it is not only dependent on radius. अगर radius पे सिर्फ dependent होता तो sodium, calcium has more hydrated radius than sodium, but still calcium flocculates and not sodium, right? So in that case it is charged by radius, and since charge is twice, the force becomes 2 into 2, 4 times. So since the force becomes so high, that is why calcium can flocculate and there will be flocculation of the colloids. So this ionic potential is a very important term that is very useful in clay colloid flocculation and deflocculation also, and here also. All these lines are from ICCS. Please read. Fate of released trace elements during weathering depends upon ionic potential. This is a very true false worthy question. Statement 1 is true, statement 2 is false. वैसे question में ही आएगा. Generally, this line is extremely important again. This line is extremely important again. Trace elements with less than 2 ionic potential are transported easily. I can already see the question, you know. There are 3 statements. In statement 1, they are telling that ionic potential less than 2 are transported easily. Then statement 2, trace elements having IP between 2 and 12 are precipitated as hydroxide. And statement 3, trace element with IP of greater than 12 form soluble oxyanions. इनमें से कौन सा true है? वहीं पे in this soluble they will write insoluble and they will mend the statement. So be very thorough, be very careful. These last slides which I showed you, these 2 slides, this slide and this slide, you should remember each and every word of these slides, you know, because all are highly question worthy statements here. This I have seen myself question from this, you know. You should remember less than 2 में क्या होता है, 2 to 12 में क्या होता है, greater than 12 में क्या होता है, right? Then fate of micronutrient in soil. Fe, Zn, Mn, Cu, of course cations है. Released during transformation are either adsorbed on the soil colloid or may become a part of the secondary silicate mineral by isomorphous substitution. That is very easy. इसमें याद रखने का कुछ नहीं है. You can remember. The micronutrient anions such as molybdate and borate also combine chemically with soil constituents like phosphates and form new reaction products. Then this again. Micronutrient, you do not have to read the whole chapter, but जितना पढ़ना है उसमें से बहुत सारे क्वेश्चन आने का चांसेस है. Like you do not have to read those solubility diagrams. Of course you do not have to read those, but you have to remember the solubility का जो ascending descending order है of the minerals. That is very important. वहाँ से क्वेश्चन आते ही आते हैं. Like definitely it will come. So those are very important. But those diagrams and then those calculations, those you do not need to read only. वो छोड़ दो, उसमें पढ़ने का जरूरत नहीं है. But this is again extremely important. What is a lithophile? Trace elements that have affinity for silicate minerals, because litho का मतलब है अर्थ क्रस्ट और पेरेंट मटेरियल, एंड फाइल का मतलब होता है लवर, someone who loves the earth crust. So earth crust is nothing but consisting of silicate minerals only, because oxygen and silicon, they form 46.6 and this is 27 point something, I forgot. So total it is this much, right? So lithophile are the ones which have affinity for silicate minerals. Very important. एकदम यहाँ से question आएगा. Among micronutrients, these examples of कौन lithophile है, कौन chalcophile है, and कौन siderophile है, this is extremely important. You have to remember this. This can come as 1, 2, 3, 4 out of these which are lithophile in that way also, or they might ask direct question also. In the last ASRB net which happened in November 2025, they have asked exactly this. Which among the following is a chalcophile? They have given 4 element names and you have to tell. Which among the following is not a siderophile? They have given 4 names. So you have to remember all this. It is very sad, I know, that remembering this much is a bit difficult, but you have to remember this. There is no other way. You have to remember which are lithophiles, which are chalcophiles, and which are siderophiles. So chalcophile, again, phile is lover and chalco means the group of sulfur. So trace elements that show affinity for sulfide minerals other than oxygen, this group includes Zn, Fe, Mo, Cu and Ni. That is called chalcophile. Then we have siderophile. Sidero, we all know, sidero means iron. Trace elements that have affinity for iron minerals. This group includes this. And atmophile. Atmophile, we all know, atmosphere. Atmophile comes from atmosphere. So has a low boiling point and are highly volatile. That is, which stay in gases, because we know atmosphere is a gaseous blanket over the earth's surface. So जो gaseous form में रहना ज़्यादा पसंद करता है, this group includes N and H. These are called atmophiles or atmosphiles. This question you can find. I have also seen. It will come, है ना? See, this has been given especially for you. You can read from here. But इतना सारा याद रखने का जरूरत नहीं है. Whatever is there in ISSS, you have to be very, very thorough with that. All right. Redox reactions are important in soil as they modify solubility relationships. This is also a totally question worthy line. This only one slide can have at least 2-3 questions, so be very cautious. Redox reactions are important in soils as they modify solubility relationships and affect mineral transformations. Lindsay introduced the P plus pH as a redox parameter. Now, lots of time there is no interaction with you. Tell me the name of the book written by Lindsay. Which book has been written by Lindsay? This question will also come. I think all of you know that. बहुत सारे मैथ्स द फॉलोइंग में आता रहता है ये. Lindsay introduced the parameter PE plus pH. पहले सिर्फ pH था, then सिर्फ P था, then Lindsay combined both of them, PE plus pH, and he gave a new parameter as the redox parameter that simplifies the handling of many theoretical redox relationships. Once you come in PhD, there is one course which totally, completely deals with this only. Lindsay ka kitab, which Pawan has written, very good. Chemical equilibrium nahi, that is plural, chemical equilibria of soils. Okay, chemical equilibria of soils. That book and that whole course is only related to this redox reactions and mineral transformation of all the nutrients: nitrogen, sulfur, iron, zinc, manganese. That is a very difficult course, but मजा भी आता है. So please remember this name, Lindsay. Lindsay ने जो किताब लिखा वो, and who introduced this concept as a new redox parameter. And out of this, I know you, all of you know, PE is electron activity, pH is H plus ion activity, right? Then again, pools of micronutrient, we all know VH gave 5 pools of micronutrients. This is also very important. वहाँ पे if you see in old ISSS, there are 3-4 pools, 3-4 concepts, 3-4 school of thought. सारा needed नहीं है. This is more than enough. VH 5 pools is more than enough. According to VH 1962, micronutrient cations exist in these soils in 5 pools: water soluble, exchangeable, complexed, adsorbed, chelated, then occluded and bound in carbonates, sesquioxides and secondary minerals, and finally these are the structural primary minerals, right? तो हम 1 से लेके 5 की तरफ जितना जाते हैं उतना it becomes difficult to release, right? Here you can see all the pools have been given. So someone was asking occluded in the last class. I think by now you know what is occluded. Occluded means binding in the interstices of the mineral of carbonates, sesquioxides and secondary minerals. Then status of micronutrient in Indian soil. This is also very important. Green schist containing highest concentration of this, while sandstone is the poorest source among sedimentary rocks. Zn is highest in limestone. Molybdenum is least abundant among micronutrients in lithosphere. Peaty, alkaline and poorly drained soils commonly have high molybdenum. Then in this it was not written. Zinc is the most deficient micronutrient in Indian soils. And zinc deficiency के वजह से rice में कौन सा disease होता है? And who gave that? Who reported that disease for the first time? Can you tell me? Pawan or anyone? Can you tell me? Can anyone tell me? Who reported for the first time Khaira while Nene? Very nice, Pawan. Your preparation is in the very right track, I must say. Khaira. Khaira disease, and it was given by Weil Nene. It was reported from GB Pant, as far as I remember. It was reported from GB Pant University, right? Please correct me if I am wrong. Can you tell me from where it was reported? It was reported from GB Pant, right? GB Pant का जो experimental plot है वहाँ से report हुआ था ना? Yes. Okay, very good. Thank you so much, Pawan. So factors affecting, we all know factors affecting में ऐसा क्वेश्चन जब एमएससी सेम एग्जाम में आएगा तब भी ऐसा ही लिखना पड़ेगा. फर्स्ट यू हैव टू राइट इफेक्ट ऑन कैटायंस, देन यू हैव टू राइट इफेक्ट ऑन एनायंस. सो इफेक्ट ऑन कैटायंस, pH will come. Low pH indicates highly acidic soil reaction in which all micronutrient cations occur in soil solution. This is because, yes, GB Pant. Yes, why this happens? Because low pH means pH is less than ZPC. pH is less than ZPC का मतलब बहुत सारा H plus है in the soil solution. So clay का जो edge है वहाँ पे जो OH है, this H plus will protonate this and it will form plus charge. All right. So it will form plus charge and this plus charge will result in repulsion. Repulsion की वजह से these micronutrient cations जो है, these micronutrient cations, these will not be bound to the soil colloid and they will be freely available in the soil solution, right? If pH of soil is higher than 7, the micronutrient cations get precipitated as insoluble hydroxides. Very nice. Under alkaline conditions, the micronutrient cations are changed largely to their oxides or hydroxides of comparatively lower solubility. Very good. Then oxidation state of micronutrient cation, lower oxidation state of Fe, Mn and Cu, the reduced states, very important, reduced states are more soluble, very important, than higher oxidation states and normal pH range of soil. High pH of soil favors oxidation, whereas low pH conditions are favorable for reduction of micronutrient cations in soil. Very easy thing to know. At lower pH values around pH 3, trivalent ferric iron gets precipitated as hydroxide, whereas divalent ferrous iron is not precipitated until pH is raised to 6 or higher. This is also important. So in this one thing is there कि यहाँ पे सिर्फ Fe, Mn और Cu लिखा है. Why not Zn? Zn का कितना state है? How many states of oxidation are there for Zn? Zn can exist in how many oxidation states? Can anyone tell? I'm very sad to see Zn is not here. Why? Zn can exist in how many oxidation states? Zn can exist in only one oxidation state, that is Zn2 plus. Yes, correct, Pawan, because mainly, not mainly, only one. There is no mainly, non-mainly, primarily, secondarily, कुछ नहीं है, सिर्फ एक है. क्यों? Because if you see the electron configuration, it is 3d10 4s2. So ये जो 4s का जो 2 है, only these two can get out and it can form Zn2 plus. You cannot touch these 3d10 electrons because these are so stable. All right. Then interaction of micronutrient cations with other soil constituents. Silicate clays contain micronutrient cations, particularly this. Then these ions are released from clay, increased by micronutrient fertilizer application. Yes, this statement is important. Then moving on, metal chelates are fairly stable and are protected against soil reaction. These chelates are readily assimilated by growing plants. Metal complex of fulvic acid have high water solubilities and are available to plants because we all know fulvic acid is soluble in everything. Then copper is retained very strongly. This is very important. What is the name of this series? Copper is retained very strongly in organic soil and such insoluble complexes are responsible for low availability of copper in organic soil. What is the name of the series? एक का नाम तो मैं लिख दिया, दूसरा साइंटिस्ट का नाम क्या था? Anyone? No, this is not lyotropic. नहीं, बिल्कुल नहीं. This is related to organic matter, Pawan. This is related to organic matter. This is not Hofmeister. You are getting confused. Copper is retained very strongly in organic soil. This one I am telling. CuNiCoZnFeMn. What is this series called? Pawan, please do not get confused like that. Please read this portion, soil organic matter. This is very... Yes, it is chelation related. It is organic matter related. Yes, Pawan, you are absolutely correct. It is William Irving series, or also called Irwin Irving series, right? It is called William Irving series, Irving Williams series, Irwin Irving series, many names, but this is the most commonly accepted name. Irving Williams series. It is related to chelation and it is related to bonding with the organic matter. This is not Hofmeister, this is not lyotropic series. Please be careful. Organic matter जब आएगा उसमें copper comes first. CuNiCoZnFeMn. ये copper comes first. That is the Irving Williams series. Huh? Please remember. Then effect on anions, we all know chlorine is highly soluble in water. Boron at low pH, most of B compounds are soluble and thus B remains available to plants as boric acid. Generally at higher pH values, availability of B increases. Boron ka, okay, my bad, no problem. Boron ka, if you see that graph, it is like this. Along with pH, it varies like this. So low pH may be highly available, high pH may be highly available, but in the middle pH, it is less available. There is this photo in DK Das that is very important. All the jitne sare bhi micronutrients hai, unka sabka the graph is given like this. Most of the micronutrient cations are having this type of graphs, where it is highly available in low pH and less available in high pH, whereas micronutrient anions are having this type of graph. But for boron, you will see it is like this. All right, very nice. Overliming has been found to cause boron deficiency in crops. Okay, fine, very good. Boron occurs mostly in organic matter in surface soil. Molybdenum gets fixed in iron and aluminum compounds as well as on silicates at low pH. So molybdenum ka curve is like this. The fixed molybdate can be made available to crops by phosphate application. This is a very important line, you know. Molybdate and phosphate ions, those are very similar chemistry wise. So if there is phosphate fixation problem, you can apply molybdate in that, and molybdate or phosphate में competition की वजह से phosphate will be released. So this is a deficiency correct करने का ये एक बात है. And again, if you want to make molybdenum more available to plants, you can apply huge amount of phosphorus. Fixed molybdate can be made available to plants by phosphate application to soil, which releases fixed molybdate ions by anion exchange, because the chemistry of molybdate and phosphate are very similar, indicating that the fixation sites on soil colloids for phosphates and molybdates are the same. ये same तभी हो सकता है जब ये दोनों ion are similar in chemistry. All right. Then micronutrient interaction, very extremely important, especially this nitrogen into zinc, very important. The antagonistic effect of N-fertilization on zinc nutrition of plants is due to dilution or poor. This you can read from ISSS. This is again extremely important. Phosphorus and zinc ka to, like it is a matter of experiment for maybe last decade or so, 10-20 years se sirf wahi chal raha hai, you know. So phosphorus into zinc, very important. Precipitation absorption of zinc in soil, P fertilization ki wajah se kya kya hota hai. This is also taken from old ISSS. Old ISSS mein there is that portion. From there you can read that. It is written all the four. You don't have to remember all the four reasons for that, but only remembering one line and the keywords is important. Here you can see P fertilization increases specific absorption of C and CaCO3, and also interrelationship of P and Z, and zinc has the ability to control the rate of P absorption by roots, possibly through some functional association. Like this is not proved, but there is some possibility. Then important soil method, this I cannot, this is extremely important. उसमें भी सबसे ज़्यादा important तो ये है, this we all know, this is the process of DTPA given by Lindsay and Norvell in the year 1978, right? Lindsay and Norvell test method 1978. इसमें जो भी whatever there is the solution का strength है, you have to remember, there is no other way, you have to remember, right? Here you can see for all the cation micronutrients, this is the same, this is the major one. For nickel also it is there. For boron it is boiling hot water method. This was given by Berger and Truog, right? Then for molybdenum it is ammonium oxalate method at pH 3.3. This is also very important. This table is extremely important. ये table पूरा याद होना चाहिए. Analysis class में, I think Rohit will explain all this to you, because understanding these are very important, and I know analysis is a weak point for the BSc people, because it was weak point of mine as well, you know, in the, because once you do it with your hands, then only you get to know, right? Here also the principle of mechanism of DTPA is very important. You have to remember what is the role of TEA, what is the role of CaCl2, why it is used, how it is mimicking the exact condition of plant roots. Everything is important from the DTPA part. वहाँ से question आएगा ही आएगा. Then this table also, I cannot emphasize enough how important is this table. You have to remember the name, the formula of the fertilizer, and what is the concentration. यहाँ से बहुत ज़्यादा question आता है. 21, 33, all this should be on the tip of your tongue. यहाँ पे समझाने लायक तो कुछ है नहीं. Major micronutrient carriers, this is also same. You have to remember this. So with that, we end today's discussion. So now it is open to feedbacks. Please let me know, how did you like the session, or how was it? We will meet just after one day. Today is 13. We will again meet on 15th with the part 2 of this, where we will cover the fertilizers, the manures, green manuring, and everything else related to that, right? And please let me know if you like today's session or what else could have been improved. If there is any doubt, anything that you want to know, you can write in the comments, not in this live chat. You can write in the comment of this video, and I promise I will be there to answer your query. Whatever is there, anything is there, you can just ask me, no problem, and I will be waiting for you all in IRI. So please, if you like the session, please let me know. That will motivate me to work harder and bring such contents for you, and we'll meet again on the after one day, right? Okay, thank you Vipin and Pawan. I hope your preparation is going very good. These last days, please do not waste your time. Read treatise. Treatise is the best book for this portion of time. Read PYQs. All the PYQs of at least last 3-4 years should be on the tip of your tongue. वो क्वेश्चन देखने से एक भी मिस नहीं होना चाहिए. That should save your time and save your rank as well. So PYQ, be very thorough with your PYQ. Be very thorough with your treatise. And also, अभी नया कुछ पढ़ने का जरूरत नहीं है. If you have left some portion, some minor portion, leave that. Do not read it now. Now is a very crucial time. Read treatise very well, and definitely the success will be yours. No problem. Before exam, I think I will take some other sessions also to motivate and to give you tips how to bring that top 10 rank and how to come to IRA. You know, because we'll be waiting for you definitely. So thank you everyone. Thank you. It was very nice talking to you. Pawan, Vipin, Anil, and everyone else who was there. Thank you so much. It was a great interacting session, and thank you.